दो में एक अंदर है इसलिए इसका सिंगल है फर्स्ट है ठीक है अब देखते हैं पिक 5 ओके यहां करना है
तकलीफ में आकर के, क्योंकि मुझे लगा था कि भाई मेरे साथ क्या प्रॉब्लम इन लोगों को है कि भाई मेरे को तकलीफ दे रहा है वो लोग। पढ़ा के पहले उनको भेजा था मैंने।
Sir, please unmute your mic. Everybody is listening.
ये कनेक्ट हो गया सर, आइए सर। सर इसको नीचे कर दीजिए ना, ये नीचे कर दीजिए सर। श्रीनिवास सर, श्रीनिवास सर एचओडी भेज दिया, मनोज से रखे कर रहे हैं। डेटा सर बता आपको कर दिया ना, क्या सर मैं डेटा से कर दीजिए, क्या अभी कर दीजिए और क्या श्रीनिवास सर कॉल कितना था उसका अमाउंट एंड्रॉइड वाले का, ये 36 ये अभी भी मेरे ये तो बोलना चाहिए।
हेलो हेलो ऊपर नीचे होता है। हेलो हेलो
Good morning. If you are trying to test out your microphone, it's working. When you say hello, I could hear you.
Okay.
Potrebbe la forma, secondo me.
Excuse me. Program is not started yet, or it is not audible to me only.
It has not started. Everybody is just waiting, and I don't hear anything from the organizers or anybody. And you are obviously audible.
Good morning to all. Good morning to all. We are going to start the program. Please wait.
Dr. Manoj Kumar, it's getting late according to your program timing.
We are starting, sir. We are starting.
We are starting, sir.
With this,
नहीं आ रहा, नहीं आ मैं सिस्टम में ना पता ही नहीं चलता है कि अपना शकल कहाँ है।
अरे इधर तो बोल लो ना, इसको करो। बोल दो ना उधर।
बोलो।
yes, sir. Yes, sir. It's unmute, sir.
आ रही
Okay.
म्यूट है।
Greetings and good mornings to all partakers. It gives me immense warmth and great pleasure to grace all of your presence on this 5 days workshop short-term course on training and practice on MATLAB for engineering solutions. It gives me tremendous contentment to welcome STEAM's personalities. I, Dr. Pravesh Kumar Singh, the host of this inaugural session of this 5 days workshop short-term course on training and practice on MATLAB for engineering solution. On the behalf of the organizing committee and mechanical engineering department, NIT Jalandhar, would like to welcome our worthy director, NIT Jalandhar, Professor L.K. Awasthi sir, in this inaugural session. I would also like to welcome our head of the department, mechanical engineering department, NIT Jalandhar, for this inaugural session. With this, I would like to invite Dr. T. Srinivas, the coordinator of this 5 days workshop short-term course, to give the brief introduction about this short-term course. Please, sir.
Thank you, Dr. Pravesh. Respected Chief Guest, Dr. Lalit Kumar Awasthi, Director NIT Jalandhar. Guest of Honor, Dr. Rudra Pratap, Professor IISc Bangalore. Convener, Dr. Pramod Kumar. Head of the Mechanical Engineering Department, Dr. Dinesh Kumar Shukla. Our coordinator, Dr. Manoj Kumar. Registrar, Deans, Faculty, Participants, one and all. A very good morning to all. Warm welcome to TechUp-sponsored 5-day online short-term course on training and practice on MATLAB for engineering solutions. Organized by Department of Mechanical Engineering, Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar. MATLAB is playing a key role on product development from idea to visualization. Engineers can enjoy the work on MATLAB as it creates the bridge between the imagination to making. The main objective of this STC are to give the training and practice on MATLAB to develop the engineering solutions, to give the solutions to the challenges and develop the skills on modeling, simulation, analysis and optimization to promote the Make in India. The main topics in this STC are programming, special curves, 2D, 3D plots with animation, curve fitting, modeling, simulation, optimization, symbolic math tool, etc. This 5-day STC is scheduled with 9 lectures, the laboratory training and practice with sessions. On the final day, an exam is scheduled with 20 MCQ on the topics covered. For this FDP, 200 participants are registered with 130 external participation. 5 participants are registered from Ethiopia, Bangladesh and France. We thank Dr. Rudrapratap for accepting our invitation in his busy schedule. Our sincere thanks to our dynamic director, Dr. L.K. Avasti, for supporting and encouragement. We thank TechUp for sponsorship of this 5-day program. Our gratitude to Dean Research and Consultancy, Dr. S.K. Sinha, Registrar, Dr. S.K. Misra, Head of the Department, Dinesh Kumar Shukla, Accounts and Purchase Department, faculty and staff, for providing the continuous support for smooth organization of this program. Finally, we appreciate all the participants for their interest and cooperation. I wish this wonderful program will train the participants to practice the MATLAB for engineering solutions. Thank you, Jai Hind and Jai Bharat.
Now I request Dr. Pramod Kumar, the convener of this 5 days workshop short-term course, to kindly address our participants. Please, sir.
Good morning to all. I am Dr. Pramod Kumar, convener of this course. Honorable Director of the Institute, Professor Lalit Kumar Avasti, Dean Research Consultancy, Dr. S.K. Sinha, and HOD of the department, Dr. Dinesh Shukla, distinguished expert and resource person, our colleagues and participants. It is an honor and privilege for me to welcome you on the behalf of Mechanical Engineering Department, NIT Jalandhar, to this training and practice on the MATLAB for engineering solutions, which has been organized by the Mechanical Engineering Department as sponsored by TQ. I wish to extend my deep appreciation to our Honorable Director of the Institute, Professor Lalit Kumar Avasti, for supporting the effort to organize this training program. I want to particularly thank the Dean and RNC, Professor S.K. Sinha, for encouragement provided for this work. I would like to express appreciation for the invaluable logistic support provided by many staff members of the Institute and Department. I am delighted to welcome all the distinguished participants. I thank the expert for accepting the invitation of this program. I also thank and welcome the resource person who have agreed to share their knowledge and experience with the participant. I warmly welcome all the other participants, representative of the different institute, observer and colleague from the NIT Jalandhar. We are privileged to have in attendance so many distinguished experts like Rudra Pratap sir and resource person as well as observer. You all are leader in this field, and I am fully confident that your knowledge, experience and expertise will provide important insight on strengthening and learning of the MATLAB. I would like to conclude by again thanking Honorable Director Professor Lalit Kumar Avasthi, who has honored us by his presence at the opening of this program. I wish all a very successful training and assure of full support of myself and my colleague, Dr. Tri Srinivas and Dr. Manoj Kumar. Thank you. Once again, thank to all.
Now I would like to invite our head of the department, Dr. Dinesh Kumar Shukla, to kindly brief about the department as well as address the participants.
Very good morning to all. Respected Professor L.K. Avasthi, Director NIT Jalandhar, Professor Rudra Pratap, Professor from Department of Mechanical Engineering and Science, IISc Bangalore, dear faculty members, participants, I, on behalf of Department of Mechanical Engineering, welcome you all to this 5-day online short-term course under T-Cube 3 on training and practice on MATLAB for engineering solutions. This 5-day short-term course is organized in a series this is the 6th course in this series, and before that we have 4 STCs and 1 Atal STC under the banner of Atal scheme. I hope all the participants will get benefited from the experience of the experts on various topics of MATLAB. I am thankful to the experts and the resource persons who agreed despite of their busy schedule during this period of the semester, and for the expert lectures in this short-term course. So I wish best of luck to all. Thank you. Thank you all. Thanks.
Now I would like to invite our director, NIT Jalandhar, Professor L.K. Avasthi sir, to kindly give an inaugural address. Please, sir.
Good morning and greetings from NIT Jalandhar. Professor Rudra Pratap ji, the esteemed professor from IISc Bangalore, and our first speaker for this session. Head of department, Dr. D.K. Shukla, then coordinator, Dr. Pramod Kumar, then we have Dr. T. Srinivas, Dr. Manoj Kumar, and Dr. Devesh Kumar, who are the convener and co-conveners for this course on MATLAB for scientific computation. And NIT Jalandhar, this institute came as Regional Engineering College Jalandhar in 1987 with a humble beginning of 100 students, and now the institute first acquired the deemed university status, and later on it was requisitioned as Institute of National Importance by an Act of Parliament in 2007. And is an Institute of National Importance in Technology and Science. We have 11 undergraduate programs, and the intake is around 1135. In MTech, we have 16 courses with a total intake of around 500, more than 500 students. And usually, institute enrolls more than 100 research scholars every year. The Department of Mechanical Engineering, as has been told by Dr. D.K. Shukla, is one of the frontier department of the institute, and the performance of this department have been excellent in recent past. The department is second to the department of electronics and performance related to research consultancy. During this pandemic time, institute has been doing a lot of R&D work, and we have filed more than 30 patents. All good work of faculty members of NIT Jalandhar. I would like to congratulate them. And also during pandemic time, we have completed more than 70 such short-term courses for the benefit of faculties, staff and researchers. So I know MATLAB has been a focus since long among the researchers, because it gives you an easy access and easy platform for simulating and looking inside a system. So basically it's a mathematical model for so many problems, and these problems vary from mechanical to electronics to computer science, and there are so many toolboxes in this. And as has been told, that it is a series of such courses, and I would like to congratulate Department of Mechanical Engineering, Dr. D.K. Shukla and his team for taking such a initiative. I would definitely like that all the participants, the experts, everyone should be connected through maybe LinkedIn community, and then the people should be able to cooperate and coordinate with each other, so that they can benefit in their research pursuits. With these words, I wish that everyone connected will be in good health during pandemic time, and humanity as a whole should come out of this pandemic time and at an early date. Thank you. Jai Hind, Jai Bharat.
Now I would like to invite Dr. Manoj Kumar, the coordinator of this course, to welcome our experts and as well as give the brief introduction about him. Please, sir.
Good morning, Professor L.K. Avasthi, sir, Director, NIT Jalandhar. Professor Rudra Pratap, sir, our resource person. Head of Department, Mechanical Engineering, Dr. D.K. Shukla, sir, and my colleagues and dear participants. On the behalf of organizing team, it is my pleasure. Professor Rudra Pratap, sir, is a professor, ex-chairperson of the Center for Nanoscience and Engineering, and an associate faculty of Mechanical Engineering, ISC Bangalore, where he served full-time till 2010, when he moved to chairperson of the Center for Nanoscience and Engineering as a founding chairperson. Professor Rudra Pratap hold a PhD degree from Cornell University, USA, a master degree from University of Arizona, USA, and a BTech degree from Indian Institute of Technology, Kharagpur. Professor Rudra Pratap joined IIC Bangalore in 1996 after teaching at Cornell University for almost 3 years. For the last 20 years, he has worked in the area of micro electromechanical system, MEMS, we say, and dynamics of micro nano scale system. His research interests include MEMS and NEMS, vibroacoustic, bioacoustic, mechanobiology, and computational mechanics. He has published more than 200 reputed journal papers. He is author of 3 books, and his books on the MATLAB getting started with MATLAB is popular among the students of engineering. He has 7 patents to his credit and 8 are in pending. He is an associate editor of IEEE, ASME Journal of MEMS, Journal of IEEES. He has an elected fellow of the National Academy of Engineering and National Academy of Science, India. He is also chairman of I2N Technology Private Limited, a company that he founded in 2010 for making nano tech hardware product. Welcome, sir. Yeah, please, sir.
Thank you very much. You have to give me the presenter's right so that I can share my screen.
Just now, sir.
सारा पढ़ दिया ना मैं बोला या तो मेरा सिस्टम खराब है या फिर कुछ सुनाई नहीं दे रहा मैं पूरा वॉल्यूम दिया सर
Yeah.
So now it is done.
Yeah, that's great. Just 1 second.
Okay, sir?
Yeah.
Okay. With this, on the behalf of organizing committee and NIT Jalandhar, I welcome once again to all and present my heartfelt gratitude to all to be present here for this inaugural session of this short-term course on practice and training on MATLAB for engineering solution. And now I would like to invite our today's expert, Professor Rudra Pratap sir, to start this session. Sir, over to you, sir. Please start this session.
Thank you very much. Thank you for inviting me to this faculty development program. It's a pleasure to be with such big audience today. A lot of our colleagues have joined from all over the place. Can somebody give me a feedback that the screen is visible? Is that is the screen is my?
Yes, sir, it is visible.
Oh.
Visible, sir. Yeah, visible.
Thank you.
Yeah, it's visible, sir.
Thank you. So first of all, big thanks to the organizers and Dr. Manoj Kumar for inviting me, and also to the participants. I noticed that they have been waiting for a long time. So let's get going. I'm going to talk to you about MATLAB for scientific computation. There is some echo, so yeah, okay, good. This is where I'm calling in from. I'm at Indian Institute of Science, Bangalore. Right now, of course, everybody works from home most of the times. This is the main building of Indian Institute of Science. And as you heard in the introduction, I wrote a book on MATLAB, and I guess that's what qualifies me to talk to you about it. That book I wrote when I was a PhD student, long time ago. That was in 93, I think, 92 or 93, something like that. But the gentleman who wrote or who thought of MATLAB, who started MATLAB, is Cleve Moeller. He was a professor at Colorado and then at Chicago. Then Cleve Moeller, I have known him for 30 years. He used to come to Cornell every year to give a talk in 80s. He started MathWorks in 1984 with Jack Little. Jack was a young guy, who had just finished his master's from Stanford. I know Jack as well. So they are the ones who pioneered this whole area of bringing scientific computation to your desktop like nobody's business. So let's just this picture is from a very recent picture, 2016, when I met Steve after a long time in Boston. So let's see what scientific computation is all about. Okay, and why are we talking about using MATLAB? Why MATLAB has become so popular all around the world in engineering? By the way, I was the one who introduced MATLAB in engineering at Cornell University, and I was a PhD student then. But I learned it from computer science department, and then I introduced to the rest of engineering. Also taught faculty members there. There are two kinds of computation that we do normally in scientific computation. One is obviously with numbers, that is numerical computation, and then a lot of the times we are always engaged in doing manipulation of equations or symbolic computation, what we call symbolic computation. Now, symbolic computation till about 30, 40 years ago used to be a domain of only humans, but then one program, Maxima, came around from MIT that started doing symbolic computation, and then of course Mathematica, as you know, Mathematica changed the whole world of symbolic computation. But symbolic computation also exists inside MATLAB, and you can use MATLAB to do this. All of us who are here, who are, I'm told that most of the participants are faculty members. So all of us sort of know these computational milestones. Long time ago, it used to be slide rules. Many of you wouldn't even have seen slide rules. When I was a kid, I saw it on my mama's, who was an engineer. He showed me what a slide rule was and how it worked. But we all have used calculators. And now that is also sort of gone, more or less. Kids today who are in engineering schools, they're not using calculators. So it has now become all personal computers, and power of computing has increased several folds. Even our cell phones have far more power today than most computers used to have just about 10, 15 years ago. So how has it affected science education, or how has it affected technical education? Speed of computation has, of course, increased multifold, and the complexity of computation that we are able to handle. So when we say that we are able to handle, what I mean by that is individually. Today, the kind of complex computations we can do on our laptop in our offices is far more than we could do on mainframes just about 15 years ago. So it has led to a lot of discovery and invention through computation. Now, computation has become so ubiquitous that you can actually compute things and build intuition. This was the foundation for all of machine learning and artificial intelligence, that you can do from computation. You can make or you can recognize patterns. You can do a lot of hidden feature recognition, from various kinds of data. And that's what builds our intuition today. Okay, so it's all of this is leading to creation of a virtual world through computation, and I'm sure that all of you realize that. So what kind of tools do we need in engineering education? What should we be teaching our students? What kind of computational tool? Now, it has to be versatile. It should have broad use. It should be easy to learn and teach, and it should be useful beyond the classroom. These are the kinds of things that you would like in a good scientific computation platform. I'm sure that everybody is aware that we have tons of we have tons of specialized packages for doing this or that. Particularly in mechanical engineering, we have finite element packages, whether it's ANSYS, Abacus, whatever. There's so many of them, and for fluids, for thermal analysis. So there are specialized packages, but we are talking about a more generic tool for doing all kinds of scientific computation. Okay? At the core of it is, that something which should be good at scientific computation. Could you please mute your mic? There is some sound coming from somebody's. Please mute your mic. Can somebody please check and see who is speaking in the background? It is very distracting. So let's look at scientific computation. What is scientific computation all about? A large part of scientific computation is linear algebra. Whether you look at, and I'll convince you pretty soon that linear algebra is basically at the heart of scientific computation. Whether you do differential equations or whatever, at the end of it, you are solving, matrix equations. So that's the heart of scientific computation. We do a lot of ordinary differential equations. Of course, you will say that, okay, there are a lot of PDEs. Of course, there are PDEs, but the only way we know how to solve PDEs is by converting them into ODEs. And that's what we do in most of the programs by discretization and by all kinds of frequency domain analysis. We change them to something that we can solve. So ODEs can be directly solved in these programs. Then there is plenty of curve fitting and data statistics that we do. Curve fitting and data statistics is obvious.
Sir, good morning. Hello.
Yeah.
Sir, all the mics, can you please mute? It is creating disturbance from someone. Some song and something is coming.
I know. It's disturbing, yes.
Okay, sir. Thank you, sir.
Thank you. So curve fitting and data statistics in experimental work, this is just invaluable. This is what we do all the time for whatever experiments we do. And today, data statistics is emerging as the biggest field that is out there, because everything that we have is generating data. Our cell phones are generating data. No matter what we do online, it is generating data. So data is becoming so voluminous that data statistics and making sense of data has become the biggest field. Nonlinear equations, graphics, and dynamic visualization or animation. These are the parts of scientific computation that we deal with on a daily basis. So you want a tool that does all of this very well. And that's where MATLAB, excels. So as I said, at the heart of numerical computation, we have linear algebra. Okay. And let's look at, what encapsulates linear algebra for all of us, in one equation. What encapsulates linear algebra for all of us is, a matrix A times a vector of unknowns X. Ax is equal to B. B is a known vector, right? So we write bunch of equations, bunch of algebraic equations, and we assemble it in matrix form, and that's what we call a matrix equation. Ax is equal to B. This is at the heart of scientific computation. How do you solve for X? right? And the MATLAB solution, this is when I fell in love with MATLAB. Very first time I saw this in 1987, x is equal to a backslash b. I couldn't believe it that this program had such a powerful operator, backslash operator, which did all the computation in the background. Till then, you were forced to learn so many factorization techniques. In school, you learn Gaussian elimination, and then as you grow up in college, you learn LU decomposition. You learn all kinds of decomposition of matrices to be able to solve this equation. And it turns out that all of that wisdom, MATLAB encapsulated in a simple operator like backslash operator. So linear systems where A is square and non-singular, it's fairly straightforward. If it is non-singular, then inverse exists, and there are many algorithms to compute the inverse. Of course, we never explicitly compute the inverse, as you know, but we factorize and we solve this equation, right? So this backslash operator understands that what it has to do when x is equal to b is with A as a square matrix. What if A is rectangular? Whenever we do experiments and we bring experimental data, most of the times we are trying to fit some straight line or a known curve through our data. All of that data fitting is basically solving a set of equations. But now you might have just two unknowns, just remember your first year or 12th standard physics experiments on spring mass systems, where you were trying to find the spring constant by hanging different weights from springs and looking at the displacement, and then plotting force versus displacement graph. Now you add many weights and you get many displacements. And what equation you are trying to fit to that is F is equal to K times X, right? So there is only one unknown that you actually want to know, which is K. What is the spring stiffness? And that comes from that slope of the line. But when you generate lots of data, you are trying to fit a straight line, which is y is equal to ax plus b. Now, that line, has two mx plus c. Let us say mx plus c, y is equal to mx plus c. All you have is two unknowns, m and b, right? And for two unknowns, you generate lots of equations. Each data point gives you one equation. So you have a rectangular matrix, right? You have ax is equal to b, where A is a rectangular matrix, x is unknowns, maybe a much smaller number in x. How do you solve this? Analytically, there is no way to solve it, right? Because if A is rectangular, its inverse doesn't exist. You don't even know how to define the inverse. But you can do something. You can multiply both sides with A transpose, and then you get A transpose AX is equal to A transpose B, right? B is known and A transpose is known, and therefore right-hand side is still known. But what happens now is A transpose A is a square matrix, and you can do factorizations on it. So when you try to solve it, you will write it like this on a piece of paper. A transpose A, inverse of that, multiplied by A transpose B, that gives you the solution for X. And this entire thing, A transpose A inverse times A transpose, is called pseudo-inverse, right? And this is how you find solution for these kinds of equations, rectangular matrix. What is the MATLAB solution for this? It's exactly the same. X is equal to A backslash B, which means that the backslash operator has enough intelligence built into it that when it sees a rectangular matrix A, then it knows that it has to do least square solution. It has to compute by doing this kind of a pseudo-inverse. So in the background, it is checking all the time what kind of matrix you are giving it, and it uses appropriate algorithms for the solution. And that's such a huge leap from what used to happen in Fortran. Okay. So this is where MATLAB gained such popularity in engineering or in scientific computation, that as far as you are concerned is the same operator and it does the magic. Now, closely associated or very close in utility of linear equations is eigenvalue analysis, right? Eigenvalue problems, they occur all the time in linear algebra, in difference equations, ODEs, PDEs, dynamical systems, all over the place. And that's why eigenvalue problems are taught in college. But the way they are taught is not very nice, If you remember how we were taught eigenvalue problems, and even today how it is taught, this is how it is taught, that x is equal to lambda x is an eigenvalue problem where lambda is a scalar and A is a matrix, x is a vector. And immediately after that, we jump to the recipe of how to solve it. In your math classes, if you remember, this is how it is taught, okay? That for this to have a solution, ax minus lambda x is equal to 0, you separate out x, you get a minus lambda I times x is equal to 0. And if it has to have a non-trivial solution, because the right-hand side is 0, the only way it can have non-trivial solution is if a minus lambda I, that matrix is a singular matrix, which means its determinant is 0. That gives you a polynomial in lambda. You solve for the roots, substitute back in a minus lambda I, and solve for x. This is how eigenvalues lambda and eigenvectors x are solved for. But this is a recipe. You first need to teach kids what eigenvalue problem means, and I'll show you that. But let us say that eigenvalue problem you are confronted with, and how do you solve all of this? In MATLAB, it's just a simple command, right? So here is your matrix A, some matrix A. Let's say this is a square matrix 3 by 3. Doesn't matter, it could be 3000 by 3000 or 300,000 by 300,000. Eig is a function in MATLAB which computes eigenvalues of A. Eig A gives you the eigenvalues. If you just put it like this, if you want both the eigenvectors and eigenvalues in this diagonal matrix D, then you just explicitly put the output here, V comma D is equal to Eig A, and that gives you eigenvalues and eigenvectors of A. How big a deal this is? That if you have a matrix, it doesn't matter where this matrix is coming from, what kind of data it is coming from. If you are interested in the eigenvalues and eigenvectors of that matrix, it's one simple command like this, and that gives you, any of you who have learned numerical computation for doing eigenvalue analysis, you will realize that how much effort we put in doing SVD computation or any of those factorizations which give you eigenvalues. It's a much bigger, much more complex sort of set of calculations. But in MATLAB, you get it with just one simple function called I. So, linear algebra is full of matrices, and therefore you have to become really good at matrix manipulation. If you are good at this, you will love doing computation. So data, it doesn't matter whether it's numbers, it's an image or a sound, whatever it is, it can always be arranged in an array or in a matrix, and you get back to matrix computation, which is where MATLAB excels. Now, I had an example, but I don't think I'll have time for it. At the heart of numerical computation is a matrix, and I maintain that matrices are just beautiful. You have to make friends with matrices. You have to sort of imbibe them and look at them as an entity and start looking at their structure. Then the beauty of matrices comes to you. Let us see some example of where you will use eigenvalue analysis, right? So a dynamical system, which is a bunch of first order differential equations, x dot is equal to fxt. It doesn't have to be linear, and therefore I leave it as f of x of t. It is non-linear, linear, whatever. If it is linear, then x dot is a times x. So if you write it in this form, okay, that is equal to some linear function of x, that the solution can be always written in terms of the eigenvalues of a, which are lambda I, and the eigenvalues vi. This is how you write the solution of. Now this x dot is equal to x could be a set of 1,000 first order differential equations or 1,000,000 first order differential equations. It doesn't matter whether it's one equation or 100 or 1,000 or 1,000,000. This solution is valid as long as you can find eigenvalues and eigenvectors. You can write the solution. Mechanical engineers, this kind of network where you have springs and masses. If you write the equation of motion, you will come up with something like this. Somebody's you write the second order differential equation, and you can always arrange it in the form of x double dot is equal to k times x. If you do it, then the very next thing that you can do is either you can go to what is called normal mode analysis, or you can set up this as first order differential equations and solve it numerically directly. Okay, if you assume that x is equal to some sinusoidal function, x is some sinusoidal response that second order equations of this form will have, and if you substitute, you obviously x is equal to a sine omega t. If you assume, then x double dot gets converted into omega square x, and if you put that back here, you come back with an equation which looks like this, and this is nothing but an eigenvalue problem. Okay, so network of masses or a network of inductors and capacitors will always result into eigenvalue analysis, right? So let me just tell you in 2 minutes what eigenvalue problems are like. This bugged me when I was a student. The way we were taught eigenvalue problems, starting with this equation and immediately turning to the recipe. This is, solve a characteristic equation, substitute and find eigenvectors, blah, blah, blah. But what is actually eigenvalue problem all about? Now, if you look at this equation, a times x is equal to y. A is an operator. It's a linear operator. Okay, A as a matrix, the linear operator operates on a vector x and gives you another vector y, right? So what it means is that if it is a linear operator, and if x, this is a vector, let's say x is a vector, A operates on it, it will always transform it into another line. Okay, that line could be shorter, bigger, doesn't matter. It could be oriented differently, but it will always be a line. It can't become a curve. Okay, so a linear transformation will take a line into only a line. It can't give you a curve. All these lines are possible solutions, meaning a times x or the y could be any of these lines, right? So all of these are valid candidates for y. Now, when you think about the eigenvalue problem, ax is equal to lambda x, then there is a big difference. All those lines must be parallel to x. The lines can only be stretched or contracted. They cannot be rotated. So it's a property of what? It's a property of this matrix, and it's a special relationship with x. So it's the relationship of the operand with the operator that defines an eigenvalue problem. That's what eigenvalue problems are all about. It's not about solving that or learning the recipe. It's about understanding what A times X is equal to lambda X actually means, right? So eigenvalue problems are not about the recipe of how to find them. They're about discovering the special relationship between operators and operands. Okay, so once you understand that, then things become very different. Now, non-linear dynamical systems, we were talking about linear. Non-linear dynamical systems, x dot is equal to fxt. It could be some non-linear function of x and t. You don't know. You can solve it directly using numerical ODE solvers. There are a bunch of ODE solvers in MATLAB. You just need to learn one of these functions and you will be able to solve them directly. You don't even need to solve them. If you just need to visualize the solution, you can look at the solution topology using vector fields. Let's say the nonlinear pendulum equation, theta double dot is equal to minus omega sine theta. As long as you keep sine theta as sine theta, it's a nonlinear equation. If you assume that theta is very small, so that sine theta is nearly equal to theta, then we say theta double dot is equal to minus omega square theta, and that is then a linear equation, and the solutions are just made of sines and cosines. But if you have this equation, the solution is not those sinusoids that you are familiar with. The solution is periodic, of course, but it's not sinusoid, right? It's made of lots of sinusoids. And it's a periodic solution which is not your pure sinusoid. So can you find that without even solving this equation? If you try to solve this equation, you get to elliptic equations, and it's not an easy analytical form. But you can always say that, okay, let's say x dot is equal to y, so y dot is equal to minus omega square sine x. You have converted into two first order equations, and you can do vector field plot. Vector field plot you can do with a function called quiver in MATLAB. All it does is it takes all these points, x, y coordinates, you can specify how many x, y coordinates. In this xy plane, you can take, let's say, 100 points, 10 by 10, 10 this way, 10 this way, or 50 this way and 50 that way. So you make 50 by 50, that is 2,500 points, you put in this grid, and at each point, you evaluate x dot and y dot. If you do that, then y dot divided by x dot gives you dy by dx. That means it gives you the slope of dy by dx. So now you can plot these arrows, that what does the vector field look like? Vector field meaning y dot divided by x dot or dy by dx. How does the slope of the solution in xy plane look like at various points? So these are the arrows, and you got the arrows, you can almost see that the solution, what kind of solution will be there. You will have here, you will have circles, right? Periodic solutions, pure periodic solutions. But if you are here, then you are not going to get those circles, right? So this is how you do vector field plots. You can use streamlines to find solutions simply by doing vector field plots and then doing streamlines to see where this, if my initial conditions are here, then where does this trajectory go? How does it evolve? So these things are so easy to do in MATLAB. Laplace transforms, Fourier transforms, Z transform, wavelet transform, doesn't matter which transform is your favorite, you can do all of it here. Graphics and animation, hang on. Intuitive plotting commands, there are function plotters, you can directly plot functions, you can do 2D and 3D graphics that you will learn, you can do 4D graphics. 4-dimensional graphics means you have a 3-dimensional graph with color thrown in as the 4th dimension to show how something is evolving. And you can do animation. So animation is something that is very easy to do in MATLAB. My students use it all the time. I have used it many times to teach things, to show how things are evolving in time. Animation changes your perspective on things so much. This is a three-dimensional curve or a helix, right? A helical motion that you are looking at. But when you look at the projection, then it looks like a sinusoid. It doesn't matter whether you look at the projection in one plane or two planes, you can see this, and this kind of thing is fairly easy to do in MATLAB, right? Sound data files, you can create sound data files, and you can produce sound from computed data. So for example, oh my God, we are running out of time. I have another lecture to give at 11:30. So sound data files, for example, I have worked on crickets. One of my students worked on trying to figure out that how do crickets produce such loud sound. It's all mechanical. They don't have any vocal cords. All they're doing is that wing that it is moving, right, in an angular fashion. It's called stridulation. Just by doing that, and they have certain set of teeth below the wing that rubs against a tough tissue called plectrum, okay, just like guitar plectrum, and that produces a frequency multiplier effect on it. And then there is a small part in the wing which is thinner. That's the harp, which resonates with the same frequency as the impulse frequency coming from this wing rubbing, right? And that's how the harp acts as an amplifier, because it's resonating. And in resonance, that the amplitudes are much larger. It gets driven to large amplitudes, and it produces that kind of motion. So this is the harp. This is the harp that resonates, in the cricket's wing. Now, what we did was we took that harp. We did finite element analysis. We modeled it, modeled its geometry, took cell elements for the harp, and for the veins we used brick elements. You can do this kind of analysis fairly easily by take the image, throw it in MATLAB, get the coordinates at the ends so that you have the geometry right. And you can create, as I said, for veins also. Veins are just tougher. You can see the veins here. That is thicker part of the harp. So that you can model with brick elements. You could do that. And after doing all of that, after understanding the material properties, doing experiments with the cricket wing to find its Young's modulus, blah, 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 all of that, we did, and we created a model, a finite element model of the harp. And, from there we got the displacements, and the displacements look like this in response to this periodic loading that was coming, impulsive loading that was coming. When this came, then I asked my student that why don't you take this simulation result and convert it into a wave format. That means convert the same thing, the same amplitudes, change it to voltage, okay, and after that play it in MATLAB as a sound file. And this is what you hear. This is your finite element model of the cricket wing. Look, it sounds just like a cricket. So you can do, graphics, you can do sound, you can do computation. MATLAB programming lets you look at programming in a very different way. You can appreciate the high-level language that it gives you, learn to think in terms of arrays, use array computation all the time, know your linear algebra if you want to do computation, if you want to be good at computation, use modular programming, and you can use nested functions. Now, I have run out of time, so I'm just going to not do this part about languages, but the MATLAB language contains everything that a structured programming language should have. Okay, it has all kinds of data constructs, arrays, structures, cells, and objects that you can define for object-oriented programming. So it gives you a a whole lot of flexibility for doing whatever you want to do. And multi-dimensional arrays, it doesn't have to be two-dimensional array that all of us know. The third dimension could be like pages in a book, lots of books stacked together on a shelf, lots of shelves in an almirah, then lots of almirahs in a room. You can keep on increasing the dimensions, right? So you can do multi-dimensional arrays like this in MATLAB. That is really good for data storage, and still all of your all of your array manipulation techniques that you learn on 2D arrays, they all hold good. So learning computation is all about focusing on the computation, not on the tool. Okay, so learn logic and sequencing, appreciate algorithms, learn language and algorithm implementation, think graphically, think vectorially. If you do this, then the beauty of scientific computation will come out live. And that's when you enjoy doing numerical computation. Okay, so this is my appeal to all the teachers here today, all faculty members. Learn MATLAB yourself first. Use it for solving classroom problems. Use it for your courses and for research. Build a suite of examples for your class. Inspire students to contribute. I have tons of programs that students have done for for my class, and then I sort of collected them, used them, animations, etc., and it becomes far more fun. So that's all I have to share with you. I've run out of time. Thank you very much. Any questions? I'll be happy to answer. Okay, let's see. And I unshare the screen. Yes. Okay. Dr. Manoj Kumar, are you there?
Yes, sir. Yes, sir.
Okay. So if anybody has any questions, quick questions, I can answer. Otherwise, I think you will have to move to the next lecture.
Sir, good morning. Sir, this is Rajashekar asking you a question from Vellore Institute of Technology, Vellore.
Sure.
Actually, so a problem can be solved in different ways. Is it right, sir?
Yes.
Is there any presumed thing that how to get an optimal solution for a problem?
Well, see, optimality comes from experience, right? That how do you attack a problem and get optimal solution? Now, in pure play optimization, of course, you use optimization to get a solution optimized, but that's not what you mean. If a problem can be solved in many ways, then you first have to use your experience, your learning so far, that what is the best way of attacking this problem. There is just no recipe for that, right? Just like in life, to know what to do in your career, is there a simple answer? And the answer is no. You have to count on your experience, and based on that, you have to try and see which one is the best answer, which one is the best method.
Yeah, thank you, sir. Thank you.
Thank you, sir. For participants, is there any queries?
If no, then I thanks to Professor Pratap sir for giving.
Hello, sir. Hello.
Yeah, please.
Yeah, hi, sir. This is Musa. I just wanted to know, like, how can we best utilize your book with like the MATLAB book? How can we use it properly?
So I can tell you how I use it. So I just look at students in the classroom who have not used it at all, used MATLAB at all, ever. So that's one class of students. Most of the students today, I mean, of course, I'm teaching only graduate school, right? Masters and PhD students. So most of them come with some experience. Some of them haven't used it at all. But at undergraduate level, first year students, most of them have not ever heard of it, right? Because they're just coming to engineering. So what I do is I ask them to do the tutorials first, just get into it. And that was the whole motivation of writing this book, how to get students going in MATLAB, right? So the first one chapter, where it's tutorials, it's hand-holding, just get the sense of how MATLAB works, just do simple computations. And after they have done it, then, so that I give as a homework, just go do it, and then come back. Then I teach them, let's say you are teaching mechanics, or you are teaching thermodynamics, or you are teaching, simple equations, how to plot simple equations and see, see what the dependencies are. They start getting used to using computers for doing something useful, right? And then you teach them differential equations. That's where it takes off, okay? When you teach them how to solve differential equations with ODE solvers, that will be the first place where they will know that if they did not have it, it would be extremely difficult to solve that equation. It's a any nonlinear equation. There is no go. Whatever you have learned about ODEs just doesn't matter. You can't solve it. But you throw it in MATLAB and the solution is right there in front of you in seconds. So that's where they start realizing how powerful this tool is. Okay, so that's how I take them. First through very simple computation, graphics, graphing functions, and then ordinary differential equations. And from then onwards to eigenvalue analysis and so forth and so on, and ask them to use it for classroom use.
Sir, at UG level, I have implemented this course here. And using MATLAB, I am teaching them all that is BTech student. We are designing, that means we are making different types of curve, Bezier curve, Hermite curve, and its simulation also, and surface also.
Right.
All this, yes. And now they are the results are very much enjoying. They are saying that this course should be implemented even in second year itself, so that we can make the number of things. If I say more circle, they can easily make it more circle.
Correct. Yes.
Yeah. They can easily make that means bending curve and all these things.
Certainly true.
Right. Yeah. Anyone else? Actually, professor has to go for another lecture.
Yes. in 5 minutes.
Yes.
Give a lecture on MEMS.
Yes, sir. Thanks a lot, sir. Thanks a lot for giving your time and valuable time to us, sir.
My pleasure. Thank you.
Thank you, sir.
Thank you. Bye.
Bye, sir. Bye, sir. Bye.
Thank you, sir.
Okay, dear participants. Yeah, dear participants, we have another lecture afternoon at 2:30, and the fundamental of this software, that means MATLAB, you will be learning there. Okay, and if you don't have that means MATLAB in which, that means software in your system, we can tell you how we can run your program on, that means cloud computing also. Don't worry for that part. We will tell you how we can make it. And along with, I would suggest everyone Scilab is open software, and we can run MATLAB in MATLAB script also there. So I suggest this is the free software. You can download. It is hardly 125 MB. You can download and you can write your that is script or a code on that platform, and you can get the result from there also. For learning purpose, that is very, very good. It is fine.
Please repeat the name of the software again, sir.
SCI Lab. Scilab. We say SCI Lab. Google it is available. Yeah, it is Google. It is available. And I suggest you can go in a Google app, Play app, and you can download MATLAB also. And there also you can learn. That means you can type your code and you can get the output. Even you can get that means the curve also, any type of curve also, any type of surface also. So that I will tell you today itself.
Thank you, sir.
Okay. Okay, everyone.
Okay, sir.
Okay, sir. Yeah.
Sir, what about attendance? Sir?
Yeah,
Hello, sir.
asking,
What about attendance?
Please, sir.
What about attendance link? Attendance.
Yeah, attendance is recording here automatically. Don't worry. We are downloading.
Sir, those who are joined as guest, that also attendance counted?
Yeah, that also. And those who have registered, only they can get that means certificate.
Sir, good morning, sir.
Good morning.
Sir, my name is Avinash. I have registered for this course. They gave me into a link, mail ID, username and password, sir. But when I click that link, it is saying page not found. So I just asked this link from my friend and I have joined. Whether I will get my certificate or I will be as
definitely you will get. Don't worry for that part. We have right now we have 4 days. I can sort out all the things, whatever. If you have registered and here it is not reflecting, we can sort out all these things.
Okay, sir. Thank you, sir.
Okay. I hope you all enjoy.
Yes, sir.
So
Yes, sir.
So next is 2:30 p.m.
Yeah, 2:30 p.m. Right. There's fundamental of this MATLAB. Along with we will solve some tutorial, and we will give some problem to you. You will also solve this along with us. That means along with me and Professor Srinivas. If you have any doubt, we will tell you.
Okay, sir.
Okay, then we will meet at 2:30 p.m.
Hello.
Okay.
Okay,
bye. Okay, bye.
Now we can leave, sir.
Yes, you can leave.
Sir, can I ask a question?
Yeah, please.
Sir, will you be giving us these recordings or some sort of study materials after the session or something like?
Yes, we will share you. We will share you. I have learned MATLAB from Ruj Pratap sir book. So one of the best book ever I have found it. I suggest everyone you can go to that book itself. One of the best books. Everything is written there for a beginner.
Thank you, sir.
Everything it is given there.
Thank you, sir.
Okay. Recording automatically. No, recording I have off. No.
আসছে দাঁড়া আসছে দেখাচ্ছে দাঁড়া ওই জানলাটা খুলে না জন্মের উত্তরে বাতাস আসে
আসো আসো এই পর্যন্ত উত্তরের সাথে সাথে তো বর্ষ আসে আমার আপনার কি আছে লেখাপড়া কি হবে না হবে না
অবশ্যই হবে হেডফোনটা
লিঙ্ক দেখে Wow, this is cool. এটা করতে পারবা কমপ্লিট
কি
দেখালি করলে কি পারি হ্যাঁ পারবো তো বলছি সত্যি বলতে পারবো শেষ হচ্ছে দেখি তো সব সিলেবাস টুকটাক কমাইতেছে কিন্তু অঙ্কের সিলেবাস কমাইনি কেন বলো দিন রামভাই
কেন
তুমি বলো কারো
তার কি করে বলবো
তো ভালো স্টুডেন্ট হলে বলতে পারে ঠিক আছে খারাপ স্টুডেন্ট বলতে পারে
অঙ্ক কি কমাবে অঙ্ক সব চ্যাপ্টারই ভালো দিবে
হ্যাঁ এগুলো কি খারাপ জিনিস
অঙ্ক কমিয়ে লাগবে
অঙ্ক করে বললাম এমনি করতে
কটা কমিয়ে দেওয়া সম্পাদক কমিয়ে দিয়ে যাবে
ভাই আসেন আসেন দেখেন আসেন চলে যাচ্ছি কাজ আজকে বলো আজ তো আপনার রাত থাকবে রাত থাকবে না এদিকে আসেন আমার পাশে আসেন এই মাধ্যমিকের সিলেবাস ঠিক আছে কমাই যায় 30% কমিয়ে দিয়েছে এই সিলেবাস ত্রিকোণ মিটার নেই একটা কভার করা আছে আর একটা অর্ধেক কভার হয়েছে আর অর্ধেক বাকি ভারতটা অর্ধেক কভার হয়েছে অর্ধেক বাকি এই অর্ধেক কভার হয়ে গেলে হিস্ট্রিতে ঢুকে আমি হিস্ট্রি আর তারপরে ফিজিক্যাল সায়েন্স আমি কভার করাই দিচ্ছি আপনি শুধু এই রাইট তাহলে যেহেতু টেস্ট মানে টেস্ট পরীক্ষা হচ্ছে না টেস্ট পেপার তো পাওয়া যাচ্ছে না টেস্ট পেপার পাওয়া যাবে কিরকম টেস্ট পরীক্ষা দিতে পারবে কি ভাই টেস্ট পেপার টেস্ট পরীক্ষা হয়ে যেতে বড় বিতে টেস্ট পেপার নিয়ে পাওয়া যাবে কিনে পাওয়া যাবে কে বলা আপনি কি পাওয়া যাবে টেস্ট পেপার
I need it.
পরীক্ষা না টেস্ট পেপার পাওয়া যাবে
Data trending ba?
হ্যাঁ
Ogo, বাংলা বই এনে দাও।
এই হচ্ছে
ঘর রং করে আমি বাংলা বই পাচ্ছি না, খুঁজে বাংলা এনে দেবা বই।
MEHAR असं MEHAR त्यांना
बदलवलं का आपलं नाव?
नाही ते स्पेलिंग मिस्टेक झाली सगळं टायपोग्राफिकल एरर
नाव लिहितो ना
MEHAR असं ते MEHAR झालं ते आम्ही एकदा एक हे केलं होतं रोल प्ले प्रहसन त्याच्यामध्ये त्याला म्हणायचं होतं हे झालं होतं ULBचा चीफ बनला
कोण
हा मेहर
काय म्हणला होता
कडा ULBचा चीफ
कायच्यामध्ये
हिने नाटक केलं होतं त्याला म्हणायचं होतं पुढा कचरा फायदा राहता तो पुढा कचरा म्हणत नाही
আবার দিচ্ছি
Right, right.
In ACT, the minimum attendance is 80%. Minimum marks is 60%.
Minimum marks is 60%. Yes, sir.
Minimum attendance is 80%.
Right.
Good afternoon to all. Is my presentation is visible to all of you? Dr. Manoj?
Fine, sir. It is fine. It is fine.
Okay, thank you, thank you. Welcome to all to the presentation on basics in MATLAB programming applications. I request the participants please keep your mics in mute condition. Okay, thank you. Okay, I'm Srinivas, working in Department of Mechanical Engineering at the B.R. Ambedkar National Institute of Technology, Jalandhar. It's my great pleasure to share my experience in the MATLAB programming, and what I did was in some of the projects using this MATLAB programming. I'm going to share to all of you. And the main objective of today's presentation is my first responsibility is to give the introduction on this programming before going to the further discussion on various process like modeling, simulation, and different types of modeling. And first of all, I'm giving the fundamental a brief. This is a very brief introduction on MATLAB programming, so that you participants can practice according to your situations, that is the background works, maybe electrical, electronics, mechanical, civil. You may practice as per this fundamentals. Some of you already may know about these basics of MATLAB programming, but some participants may be new for this MATLAB. For that, it's our responsibility to give the brief introduction on this programming. The MATLAB is one of the powerful tool for every engineer, irrespective of their background, to excel their profession in any type of profession, maybe at the student level, faculty level, or at the industrial level. So what type of benefit you can get by acquiring the knowledge or practice in this type of computational tools is you feel easy and you may save more. You may save the time for the computations. So a lot of benefits you can get it, and you can also enjoy while working in MATLAB, especially in the engineering field. You definitely you feel certain satisfaction by getting a reasonable results, which is going to match with your experimentation and laboratory observations. So this is the outcome of today's presentation. I am going to give you the process, especially the very important process of debugging after finishing the computer programming, because at the initial level you will get a lot of errors, and to minimize the errors and to get the expertise in computer programming, especially in the MATLAB programming, how to do the debugging in a more effective way, and at the same time to save the time in the debugging process. That's I'm going to explain with some of the examples. And few plotting options like simple plotting and 2D, 3D plotting I am giving, and anyhow Dr. Manoj is also going to explain some of the options in curve fitting and graphical user interface systems like 2D, 3D plotting, etc. And this presentation also includes certain like switch case, loops like for loop, if statement, some iterations, how to do the iterations, especially to solve the engineering problems, and while loops, switch case, and some function programs. MATLAB is very flexible to do the function programming. That is leads to tools like toolbox. Various type of specialized tools are available in the MATLAB. So how to make the functions, especially specialized functions, to solve your engineering problem. This is one of the, I can say this is the one of the good feature in MATLAB compared to other languages, because in these functions there is multiple functions you can do, and there is no strict rules in calling the functions, because one functions to another function you can go, and there is a cross travel of these functions is also possible. And also sometimes you have to repeat many engineering problems and one particular set of complete plant level or the process plant level. So instead of repeating the certain levels of lines in programming, they can be, you may group as a function, so that you can save the time, and also the total length of the programming also you can save. It looks very simple like your notes, so it is easy to convey the programming to the others, to explain the others. And one interesting feature in this MATLAB is you can make animation. You can make the animation with the results. Generally, the result means if you are running a program, you will get one result. Let us say the output is also the megawatts for energy systems you are operating, or some force you are showing as you are executing as a result. If you are plotting, that means like analysis, you are changing some conditions of the parameters, you will get the plots like family of curves or singular multiple curves, you can get it. But if you are adding the feature like animation, so what are the MATLAB programming you can also use for the teaching. Today morning also discussion happened how to use the MATLAB and at various levels, like not only research, we can also use this MATLAB for teaching purpose in a more effective way. We can teach my experience of this MATLAB in my subjects also I am going to share, especially the feature, I included the feature of animation so that it's easy to explain, because you can control the time phase, means rapid movement or slow movement like slow motion, so that according to your phase, to explain the students, to convey the students, you can control the time in the animations. That also I'm going to explain to present the results with the animation. That's moving parts, moving results. I can say this is moving results. And here anyhow, this all the numbers in this MATLAB we are treating as a matrix. The MATLAB is mainly, it is derived from the name matrix laboratory. That's why every number is almost, it is a matrix, even though it is a single number. Let us say x is equal 1 or 2. That is also treating as a matrix. So generally in the MATLAB programming, the numbers we will assign in arrays, maybe single one-dimensional or multi-dimensional array. So it's handling of these variables or the numbers with arrays is very easy, and you will feel some more flexibility, because one variable is representing so many numbers, maybe thousands of numbers or hundreds of numbers. You feel more flexibility by handling these variables in terms of arrays. As I mentioned, I am going to share some of the applications here. The applications includes both the students as well as this faculty, because the participants, I saw the participants, students from BTech, MTech and PhD, research scholars, and also I saw faculty. So I am going to give the examples for students and also for the faculty. Since I am the faculty, I am going to share the applications of this MATLAB, some teaching, some of the examples on the subjects. Even though the subjects are related to my specialization, depending upon your specialization, you can apply these conditions. That means we are converting these MATLAB results to your subjects, and in my opinion, there is no any limits to this MATLAB. According to your building or according to your imagination, you can shape this MATLAB programming or toolbox into your teaching level or project level or research level. So first, I want to convey some of the important points we have to remember while doing this programming. The first one is MATLAB code is case sensitive. We have to keep in mind the uppercase letters and lowercase letters. And while giving the name, because after typing certain lines or complete lines of this programming, initially the name comes as an untitled. After that, we have to give the name for the file, that's MATLAB file. It is also called as a script file, is represented as M file, M.dot file. How to give the name? That's the first letter should be alphabet, and we should not start the first letter with the numbers, and also we can't give the space between one word to another word. For example, there is a subject, fluid mechanics. You are making the solutions for the fluid mechanics subject, or maybe projects and the fluid mechanics. We can't write like fluid space mechanics because that is error. But unfortunately, after running the programming, MATLAB programming, it won't represent this very specific error, like there is error in the file name. It won't execute. We feel like a puzzle. All the lines are correct, but still it is not executing. Then the problem is the error in the name. That's why we have to keep mind while giving the names to this MATLAB file. We should not use the space or the gap in the name. And I told you the MATLAB file should not start with the numbers. It must start with the letters, maybe uppercase letters or lowercase letters we can use. And you may ask, we should not use the space, okay, we should not use the starting letter number, but in middle we can use the either numbers or special characters, like I told you just now the example of fluid mechanics. If you want to keep the gap between the fluid and mechanics, instead of space or the gap, you may type underscore, for example, fluid underscore mechanics. So you can't combine the fluid and mechanics. It looks like a separate, like a space, fluid mechanics. So that alternatively, instead of giving the space or the gap, you may type underscore. And there are plenty of inbuilt functions in MATLAB programming. Initially, during starting the practicing of the MATLAB programming, you may not be aware of all these inbuilt functions like minimum, maximum, average, product, etc. That's all the mathematical functions are available, starting from the differentiation to the partial differentiation, integration, etc. But by practice, you will familiar with various types of these inbuilt functions, so that finally, once you are getting expertise on this MATLAB programming, initially your length may be more. Let us say the hundreds of lines you are developing to solve your engineering problem. But after certain time of experience, instead of typing so many lines, let us say the 5 lines you may replace by 1 line by typing inbuilt functions. And while writing computer coding, any computer coding, it may not be MATLAB, my suggestion is for all these participants, maybe students or the faculty, better to type some text like comments, so that it's easy for you. For example, if you today you developed a computer coding, and if you are not adding any comment for each and every line, tomorrow you may forget, because this is a completely looks like a language. It's not like your notes. Notes means very clearly you may write explanation before writing the equation. The equation consists of, and you also describe in the equation where A indicates, B indicates, etc., like a nomenclature. But in the MATLAB, there is no such, we are not writing like a notes. It's completely the language of mathematics. That means you are writing the equations one by one, first line, second line, all the lines. That's why every line, if you are adding one comment for each and every line, later it's easy to retrace the the main the logic involved in each and every line, and it is easy to continue also, because every time your problem may engineering problem may be revised. While revising your problem or while refining your problem, you need to get back what is the logic, earlier logics you applied in each and every line. That's why I strongly recommend add the comments for this computer programming, so that you feel more easy while executing as well as while refining your computer programming. And for example, you may feel while giving the results in x-axis as well as the y-axis, you may feel the alphabets as well as the numbers, some special characters only we can type. In addition to that, we can also give certain variables and with subscript as well as the superscript, what we are using in the like a textbook or Excel file. For example, x-axis we are showing as y cube minus x square or minus a2, etc. Like you are giving an equation. So using this underscore for the subscript and this power symbol for the superscript, you may use. And sometimes you have to use, for example, 2 times we are using subscript or 2 times we are using the superscript, like x power 22. Then what we have to do, 2 times we have to type this either subscript symbol or superscript symbol. And there are 2 types of variables you are going to handle in computer programming, because the programming I can classify into the main program and function program. The variables involved in the main program is called as global variables, whereas the variables involved in the function programs is called as local variables. Anyhow, we will focus mostly on global variables, because your main problem involves on the main program, where starting from input to the last ending with the representation of the results, maybe the number or plotting. In middle you can use a lot of functions, but inside the functions, what are the variables you are using, that is a local variables. It's not required for you as a main objective, because the main result you are getting from the function program, that is more useful for your main program. But we have to handle, while developing this main program and this function programs, we have to handle global variables and local variables. You may ask, sir, what is the need of this MATLAB? Because we have a lot of other programmings like C language, C++, Turbo C, etc. And what is the specialty of this MATLAB compared to the other languages? Definitely, I can say this MATLAB has more potential, because before, most of the engineers before entering into the MATLAB, they might be experienced the other languages, maybe Fortran 4, Fortran 44, 77, C language, C++, Turbo C, like stage by stage I am saying. So they knows the difference between the earlier experience in the computer programming and what are the limitations of earlier languages, and how we are rectifying or overcoming those limitations or the problems in the earlier programming, and what type of flexibility we are getting from the MATLAB programming is. The first one is in other languages, especially in the C language, in the very beginning, we have to declare all the variables. Without declaring the variables, it won't proceed. For example, if you are doing a project, generally project means it involves number of variables. Let us say there are 100 number of variables are there in a particular project. Classroom means it may be for 5 to 10 variables, it may be you may handle, but once you are solving a realistic problems, it involves a lot of number of variables. So in C language, what we have to do, we have to list out all the variables. Let us say A, B, C, D, P, whatever it may be the name, all the names we have to list out. For example, you listed out of 100 variables, you listed 99 variables. One variable by mistake you didn't type, you didn't declare it as a variable. Then what happens? Once you are developing the main program, obviously you will use all the variables, all 100 variables you have to use in the equations, but one variable what you didn't declare it as a variable, once you are using that time it will create as error. So but in the MATLAB programming there is no such issue. Without declaring the names of the variables, straight away you can start your programming. That is one of the facility I can say is available in the MATLAB in the initial stage. And MATLAB has a lot of other options like Simulink and toolbars and specialized functions are available. So Simulink is an additional benefit you can get from the MATLAB, especially from the field of the chemical engineering and also electrical circuits, electronic engineering. The Simulink is one of the essential tool to simulate some of the engineering circuits as well as some of the process conditions. And I told you the functions has more flexible, there is more flexibility in use of these function files in this MATLAB. For example, in C language, once you are designing one function file, you have restrictions. For example, main program to function program only, you can, the journey is there. But one function to another function, you can't give the link. But in the MATLAB, there is no such rules. You may give the link from main function to main program to the function program, and also from one function program to the another function program, another function program to the another function program. There is no rules and regulations while designing this function programming. That's why I can say this is a great flexibility we can enjoy while creating the plenty number of function programs in this main programming. And generally the engineers will love this MATLAB because of this beautiful graphic facility. What are the results you have if you plotting in the Excel file? It's like a conventional mode of representing your results in Excel, because that is a very routine representation like X input. You are showing input as x-axis and output as y-axis, and you may plot like some family of curves, maximum level as in say y1, y2, y3, etc. But in MATLAB there is a great flexibility. I can say there is no limit to express the results, especially in the more professional way. I can say in a more professional way. An engineer will present the results in a one particular style. If you see the style of a market engineer, like a sales engineer, he will explain the results in a different way, different style. So one person to another person, or one field of engineering to another field of engineering, the way of presenting the results or way of expressing the graphics results, maybe plots or bar chart, whatever it may be, is case to case it will change. So according to your style, you may select the various features available in this MATLAB plotting, especially in the graphics. That facility you can see, including animation. I am saying the results plotting, including animations. That type of facilities you can see in this MATLAB outputs. There are plenty of mathematical functions, inbuilt functions are available in this MATLAB. In fact, engineering is without mathematics there is no engineering. Mathematics is mathematics is the backbone of engineering. To make any product or to develop anything from science to engineering, like physics and chemistry, the mathematics is more essential tool. So to use this essential tool in a more effective way, at the same time in a more easy way, you may use this MATLAB as a powerful tool or a weapon to solve a complex and more tedious problems using this MATLAB mathematical functions. And there is no limit to also in this MATLAB. You can type thousands of lines in this MATLAB programming, Other programs you may get some problem like once you are typing so many lines in C language, let us say some thousands of lines or 5,000 or 10,000, there is a one issue will come, it will display memory exceeds. Once you are running the program, that's a C language program or any other program, it will display once it is exceeding this number of lines, it will display the memory exceeds. But in this MATLAB, there is no limit. What are the practical or real situations, everything you can simulate, and according to your models, you may prepare the models with n number of lines. You won't feel like limit in memory or limit in not able to execute your programming with the more number of lines. There is no such problem associated in this MATLAB programming. The user-friendly scripts, you feel very easy. Actually, I'm giving the introduction of this MATLAB programming, but I can say maybe 1 or 2 days you may be very familiar with all types of these commands, scripts, etc. Because it is easy to learn. Because every engineer may be first year, he may be familiar with any one of the language like C language, etc. That's maybe enough, like prerequisite, and automatically maybe 1 or 2 days once you are learning and practicing this MATLAB, you maybe get more like a friendly, you feel like a MATLAB is a good friend. Once you have a good friend, you feel like a more potential to do your problems. And there is a in engineering there is a concept, double diamond concept. From starting from the idea to market level, to implement your ideas to product making or process making, and implementing at the market level, there are various levels of steps, starting from discover of your idea, getting idea to deliver to the customer. In middle you may see the steps here, discover, define, develop and deliver. Out of these four steps, getting idea, everybody will get idea. But next problem is how to convert the idea in your mind or flash in your mind into reality. That means into the shape of product or hardware. In middle, there is a lot of planning steps are there available, like designing, modeling, simulation, and also like execution, manufacturing, making, developments, etc. Out of these steps, you can see the define. The first step is define after getting the idea or after discovering an invention in your engineering. What is the first step? You should be able to define your problem or idea or project. How to define? Definitely the MATLAB will help you clearly define your idea into understand the customer level or engineering level, because in middle the lot of people will involve, maybe worker level, supervisor level, the engineers and managements, and then finally it goes to the customer. But in between you, the inventor, and customer, lot of chain is there. So to define each and every step, especially at the planning level, I am saying the planning level, you feel more easy once you are taking the support from your friend. Now your friend name is MATLAB. Definitely MATLAB will help you to clearly define your problem with some reasonable results, as well as this imagination to the reality. See, in the first step of this introduction of this MATLAB programming, I'm giving some of the windows here. There are 3 windows I'm showing in the MATLAB. Once you open the MATLAB, for example, this is the MATLAB window I opened. One window you may see the script file is all are you may see .m, the name m.m, and command window. So here there are different windows are available in your once you open the MATLAB the file. The first one is, see, this is a command window. In this command window you may see the symbols, the 2 symbols, the greater symbols. After these symbols you may type according to your instructions. That means this command window you can enter the commands like data or numbers or some variables, you may create some programming to get the values or the answers, like maybe in the form of result or in the form of plot. This is a command window, but this command window will execute only, we can't save the script from this command window. That's why whatever the programming we are doing, that we can't save in the command window, we have to save in the script file. This is the script file what I am showing here. What are the another windows available in this, you can see in this display. This is a workspace. This workspace which lists all the variables in your programming. For example, you executed a program. In this program, let us say there are 100 variables. The variables may be single number or it may be arrays. All the variables, you may see all the variables in this side, that's a workspace side. If I want to see the numbers in one assigned variable, let us say there is one array, a two-dimensional array. Once you are clicking this array, automatically you can see all the numbers involved in these variables. I will display, I will demonstrate all these command window and these variables from this workspace while executing the program. And one more window you may see here, this is the command history. This command history works as a diary. For example, you executed a program in MATLAB. When you executed, it will record, like see here, when you executed here the day, you may see the date and the time. You may see the date and time. So like a diary, each and every activity during this debugging or executing of your files, everything will be recorded in this window. That's why it is called as history window. It will display all the log of your commands used while doing the programming. In addition to this command window, etc., you can also find some additional windows. One is graphic or figure window. In this graphic or figure window, once you are executing the results like plot options, the results you may see in the another window, separate window will automatically it will open. That window is called either graphic or figure window. And I showed you some of the programming that that window is called as M-file editor or debugger window. In this M-file editor, you can see the set of instructions to solve a particular problem. That set of instructions involves the input commands, the execution of these various equations, and finally the output commands, maybe in the form of single result or it may be a plots, the various graphics plots. So everything you may see in the script file, that is also called as M file. In this M file, you can see the various debugging options. At the top side of this screen, you may see this is called as script file. We are calling as M file. At the top of this, you may see the various debugging options like run. This is let me quit this debugging. This run and this step. Let us say this is the step. I am giving one step. After this step, you may see the step and step in, step out, and various commands are available. For most of the commands, you may see not only browsing these symbols, and also you may also have certain function keyboard. In the keyboard, you may see, let us say F10, F11. This is F11 is for step in. So the debugging you may see either using this keyboard or using this mouse, your mouse, by browsing the commands in this debugger. So the debugger window is also helping you to execute your program, that's MATLAB program, and also to debug all the lines one by line. Also you may cross check whether this is error free programming or not. Now coming to the laboratory constants, you may see the constant, scalar constant and vector constant. In the scalar constant, you see the scalar has only the magnitude and there is no any direction. The meaning of direction in the MATLAB is it's like a location. I can say this is the location or the address. Let us say in the matrix, If you are able to define the location in terms of rows and columns, that I can say that is as a address. In vectors, you can give the magnitude as well as the location. Whereas in the scalar, we can't give any address because that is only single number. But in the MATLAB, automatically whatever the number, the single number or the scalar, also it is treating as a matrix. So that matrix size is 1 by 1 matrix. It's as a single number. So what I can say finally, the every number in the MATLAB it is treating as a matrix. As for example, see the x is equal to in this matrix, the single row 1, 2, 5, 1. The location of first number is 1 and the second last, see the fourth number, that is also the value of the fourth number is also equal to 1. So to call the first number, let us say x1. If you are calling x1, that's equal to this number value is 1, and if you are calling in x in bracket 4, that is assigning to this number is 1. So if you want to call this number 5, so x3, that means x in bracket 3, that calls the third position of this value. So the vector has the magnitude as well as the address. You may see once you are typing the matrix in square bracket, x is equal in square bracket, you are giving the numbers. So it is displaying, it is equivalent to x is equal 1 to 5. If the matrix consists of so many rows, let us say this is the first row, 1, 2, 3 is the first row, second row, 1, 5, 1, 4, third row, 3, 2, minus 1. Each row you may separate by semicolon. See, that's equivalent to 1, 2, 3, 5, 1, 4, 3, 2, minus 1. Let me run this two-dimensional matrix on this MATLAB command. This command window. Now you may see that every row is separated by the semicolon, the first, second and third, and it is displaying this matrix. This is the 3 rows and 3 columns. So this is a 3 by 3 matrix. In the second line you can see the transpose, y is equal to x dot this transpose apostrophe s. So it is converting the rows into columns and vice versa. This is one of the important point we have to remember while creating the vectors, because while doing analysis, the first step is we have to change the conditions. For example, we are doing the experimentation on engine, let us say petrol engine or diesel engine. What you will change while doing the experimentation or while doing the analysis? You will change the load on the engine, let us say the off load, full load, 1/4 load, etc. And speed also will change according to your experimentation. See, accordingly, if you want to change a variable, let us say x is equal to 0 to pi. Pi is 3.14. Here, in place of pi, we are writing pi. Because pi is a special character, we can't type in this MATLAB. So the meaning of this 0 and colon 0.5 and last number is the pi. So the first number is 0 and the last number is the pi. Between the first number and the last number in the steps, you may see the steps is typed in between the first and final as 0.5. So this is equivalent to x is equal 0, 0.5, 1, 1.5, 2, 2.5 and 3. Now you can't see the next number because the final number is pi, that is 3.14, but you gave the steps 0.5, that's why you are not able to display the last number, that is a 3.14, because your steps, you consider the steps as 0.5. So how to solve this problem to represent this pi as So instead of giving this 0.5 this difference, the steps, if you see the x is equal in space LIN SPACE with in bracket see the 0, 5 and the last number represents the number of values. So it is showing 7. So 7 values, it is generating 7 values. Let us say x is equal 0, 0.52, 1.04 and 1.57, 2.09, 2.61. Last line you can see the last value 3.1416. Giving the number of values instead of step, because we don't know exactly what the exact step between the various steps. That's why instead of giving this step, if you want to display the first value and the last value, this may be better. In one of my work also, one of the project, I had to represent the time intervals, the experiment in solar energy. I am working in solar energy. In solar energy, the first observation is during the sunrise time, and the last observation is during the sunset time. If I am giving, let us say as usual, if I am giving 1 minute as a difference, I may miss the sunset time, because the difference is, it's not exactly 1 minute. It may be less than 1 minute or it may be more than 1 minute. So instead of giving the 1 minute difference between the sunrise and sunset time, if I am giving certain values, let us say 200 values or 300 values, that you may cross check later whether you are getting, because your expectation is you want to make the time gap with 1 minute. You may cross check later whether it is coming close to 1 minute or not. But initially randomly we have to declare the number of values, let us say 250, something like this. Then you can see the first value, that is the sunrise time observation, and the last value, that is the sunset time observation. This is the example I use this line, that is the line space, while preparing the time scale from sunrise to sunset. And last one, see, in case log space equally spaced intervals in logarithm space, x is equal log space of 1 to 7. In this example, you may see the 1 represent log space, 1 represent 10 power 1, that is equal to 10, and the second value 2 represents 10 square, that's last value is equal to 100. Between 10 and 100, how many values we are expecting? 7 values we are expecting. That's why you may see the values here in this x log space. Once you are working in the logarithmic space, 10, 14.67, 21.57, 31.62, 46.41, 68.12, and finally last value you may see that is equal to 100. This is also one of the important point we have to keep in mind, because this is also useful. I used in my many of my projects, maybe in the execution as well as displaying the results. See, let us assume there is one matrix, there is a m by n matrix, there is m number of rows and n number of columns. Here we have 2 rows in this matrix A, we have 2 rows and 3 columns. So sometimes we have to handle this matrix, maybe we have to pick the values, not all the values, I am saying few values while preparing certain projects like properties and making some interpolations, linear interpolations, etc. For example, from the steam tables while solving the thermal power plant. This approach may be useful. See, in the first line, A in bracket colon comma 1. A bracket colon comma 1 indicates this first one is the colon. After the comma, what we are putting here 1 represents the first column. So you are calling the first column only. You have 3 columns. Sorry, you have 3 columns, but you are calling only first column. Then to call this first column, that is first column, what is the numbers here? 0.995 and 0.23. So how to type the line here? A colon comma 1. If you are typing 2, it is calling the second column. For example, I am giving the Example of property chart, for example, there is refrigeration chart and psychrometric chart properties, or maybe steam tables. For example, let me take the example of steam tables while solving the thermal power plant. In steam tables, you have the pressure column or temperature column. If I want to pick the pressure as a main reference to do the interpolation, then I may select the pressure column according to my calculations. That type of option is available in this indexing of this matrix. See the second line. In the second line, matrix here, how you are calling 1, 2 to 3. 1, 2 to 3. For the first number 1 is represented. This is the first row. Okay, you are focusing on the first row. In this first row, what values you need? For example, you are doing the linear interpolation between these two values. So I want 0.6068 and 0.4231. So 2 to 3. First row 2 to 3. First row, second to third you are calling. This is common to all the languages, operators, arithmetic operators. There is no much difference between the other languages and this MATLAB. Let us say plus, minus, multiplications, division. But there are two types of divisions are available in MATLAB. One is the forward division, backward division. That means it is called as right division and left division. So you may see here the left division, the operations A by B, that's left division is effectively the same as inverse of A multiplied by B, although the left division is calculated differently and is much quicker. So while solving this matrix, generally let us say Ax is equal to B. Ax is equal to B, okay. X is equal, how you are solving X? By you are calculating the inverse. Instead of using A by B or B by A, what we are doing, we are calculating the inverse of matrix A and multiplying to this B. Then we are getting the answer like value of X, that is the answer we are expecting. Without doing this inverse, we can also apply these divisions like left division, so that in a more effective way you may solve this matrix. The power symbols in C language, for example, x power y, how you are solving the x, showing this x power y, you are writing POW in bracket x comma y for other languages, but in MATLAB use the power symbol, that is x power symbol y. I told you already, transpose is used in the matrix that to convert the rows into columns or columns into the rows. Okay, in the right hand side you may see the element by element operation for this multiplication, division, the power transpose. The meaning of this element by element operation means, for example, if you are multiplying the matrix, let us say matrix A and matrix B, in the standard format, how you will multiply the first row and first column. Okay, the first row, first column, first row, second column, and so on. Like that, you will multiply according to the definition of the matrix multiplication. But if you want to multiply the matrix, let us say element by element, the first row with the first row and second row with the second row, or first column with the first column, and so on, then instead of using this inverse or this left division symbol, how to do this operations is we have to type element by element, that is dot, use this dot, dot star dot, this slash or dot symbol of this power. Similar to arithmetic, there is a relational symbols. You may see logical and irrational symbols here. Equal, double equal, and not equal, less than or equal, greater than equal, and or not. This is an equal to not. This can be used in logical operations like if statement. And flow control, see here the if statement, the one is the if statement or switch case, for loops, while loops, and continue the statement or break the statement depending upon the situation. See, if sometimes the loop we have to continue according to the condition, or sometimes you have to break the loop. For example, you are picking the maximum value or the minimum value, or you are doing some interpolation. One particular point of state, we have to stop this comparison, or we have to stop the interpolation. Once you reach that condition, let us say the if statement, you are giving the one typing one state, one constraint or the condition, then the condition is satisfied means you have to come out from the loop. To come out from the loop, what we have to do? We have to break the statement. That time you may use this line, the break. Otherwise, we can continue. See, so for example, if A is greater than B, you may see this is greater, or else A is less than B, it is less or equal, and then you may see this is the if statement. The construction, you may see the algorithm if, else, and finally it is closing with end. So one if is closed by one end. Similarly, in the for loop, one for loop is closed by one end line. Let me explain this for loop, even though you are aware about all these flow control lines. Let us say for x is equal 1 to 10, so x is equal to 1, 2, 3, and so on up to 10. And let us say r is the radius, or 1, r2, r3, etc. that you are assigning into this. Well, what are the values you assign in x, variable x? Same you shifted to another variable. Let us say it is r, or the radius in the formula. Okay, output commands. If you want to display the output, that result as output, that single number, it may be the integer or floating point or exponential, or both exponential, floating point. And there is, according to the format, you may type these values, that is a percentage symbol, and D for integer, F for floating point, E for exponential. And new line, the slash by small n, which represents the new line character. So your answer, that's the display is coming next line, that's a 1 by 1 line, and tab character T is a tab character, and F print, this is the example. F printf is showing this variable name, and this variable you may show as output. Once you are typing this one, what are the value it is assigned in particular value of variable, let us say x, that it will represent that value you can see. And the string yes printf also you may define according to your variable. Let us say the floating points, how many digits you are expecting, 2 digits or 4 digits, according to your required accuracy also you may design the output command. Sometimes you have to prepare the computer coding. Let us say you have to give some commands like input. While designing a boiler, first you have to enter certain commands like design variables like what the boiler pressure or boiler capacity, etc. That time you may type, let us say x is equal to input, enter x. Input you may write enter boiler pressure. Then you may once this prompt is coming in while running your command, that's line by line, immediately in the command history window you may enter the value of the pressure or the capacity according to the instructions. Sometimes you may display your results in the tabular form. So the first one what I am showing, it is a printf is giving the values in the numbers, and sometimes you have to, most of the engineering problems may be plotting or tabular form. In the tabular form, how to represent the tabular form? You may create the columns. First of all, you may create the column. Let us say the first column is a serial number, or here it is a state, and certain variables like flow rate, m, and finally you are showing this is the error in percentage in a particular project. Then see all the variables you may assign into one particular variable. Let us say z is equal state, x, t, and t error, etc. Then once you are typing display all the columns. Why I am saying this is the columns? Because let us say once you are assigning the variable state, it will show the rows only. One serial number, you are showing the serial number. Initially it is a 1 2 3 4 in the row, in the form of row only. But in the tabular form, all the rows you need to convert into the column. That's why you may see this is the apostrophe s here for every variable. So the rows are converted into the columns. Each column, the first column, second column, every column is displayed here as a tabular form. Or you may assign one particular variable, let us say t is equal table, list out all the columns. This is the first column, this is the last column, error is the last column. And not only displaying the numbers, you may also display certain text, like let us say some instructions you are giving while preparing the computer coding. If you want to receive certain feedback, let us say you are executing certain loop. While doing the loop, it may sometimes it may leads to certain mistakes. Then those indications you may display while making some of the loop. Then you will get alarm. Then you may stop the simulation and you can do the corrective action. Now this is one of the very important tasks in computer programming, MATLAB computer programming. This is called as debugging process. Execution of this MATLAB code. Let us see some of the commands here. The first one is run. To run this program, we have to press F5. There are two steps here. One is step and stepping. Only step is F10 for every line by line execution is called as step. If you want to execute from main program to the function program, that time we have to use this stepping. That's the key name is F11. I will show this difference between the F10 and F11 by showing this example. As this example is ready for you, here one program I am running to show the debugging process. Assume this computer coding is completed and you want to check the errors for each and every line. Let us say line. There line, as you can see, the first line is showing the title and second line is clear, and CLC means all the screen you can clean here. All the screen is clear here. And line by line, I have, for example, I have doubt in line number 9. Then you can put your stopper. Putting stopper, that is called as set or clear breakpoint, F12. Either you may press F12, that is function 12, F12, or you may cursor, you may say, for example, I am pressing the cursor on line number 9. Just I am pressing cursor on, instead of pressing F12, you may press the cursor. Okay. Because other lines I am clear, there is no doubt, I have doubt only from line number 9 onwards. So you can save certain time here instead of checking each and every line. Straight away you may press the F5, or you may see here triangle, green triangle symbol, it's showing run. Yes, I am running this program. Once it is run, it is asking, see prompt here in the command window, enter pi. It is a solar energy. Pi means it is a location, it is asking location. Latitude, let me give the Punjab Jalandhar latitude, let us say 31 degrees in Jalandhar. I am giving the latitude according to my location. It is solving the solar sun earth geometry. So now you can see the green color arrow. In this green color arrow, what it is showing? It is completed line, let us say the whatever value I am giving 31, it is representing, and number of days 365 days I selected in this count for loop. Let us say January 1 to December 31st, I selected 365 days here, and and for each and every month also you may see January 31 days and February 28 days according to this year I am saying. 31, 30, 31, like this. According to the January to December, the number of days has been selected. Okay, from here onwards, if you want to execute line by line, what we have to do, we have to press F10. I am pressing F10, or the straight away you may browse this symbol, arrow symbol. What you are seeing, you may see the cursor is jumping from line by line. Okay, this is called as step-by-step operation by pressing F10, or a step operation. Okay, now I want to demonstrate the difference between F10 and F11. Straight away I am continuing, I am jumping, and I reached line number 73. Are we able to see the lines? Because these small letters in my screen. If you are using computer, yes, it is fine. If you are using phone, cell phone, it may be difficult to see it is small numbers in the computer coding. I think majority
it is visible in
using,
phone also.
Thank you.
Yeah,
thank you.
somebody asking something. Can you?
Sure.
Please say loudly.
Yes, sir. It is visible.
Okay,
then it is fine. Then it is, sir. Sir, please continue, sir.
Okay. So now I am showing the difference between the step and step in. See, now the cursor is line number 73. Now I have two options. If I don't have any doubt on this function, let us say this line is showing the function for SORAD, means it is the solar radiation. I am giving particular day January, and January 1st, let us say it is the first day, January 1st, I am giving the time 12:40, and this is a Jalandhar. So what I am seeing, I am transferring certain variables, that using that variables in Jalandhar, it is giving the data. Now what is the sun, how much radiation we can receive, what is today day length, everything it is doing, and it is giving as a result. If I don't have any doubt, straight away I can jump from 73 to line number 73 to 74. Then what I have to do, I have to press, during this debugging, I have to press F10 instead of F11. If I am pressing F10, that is run to the next line, what happens, the cursor will move from 73 to 74. But if I have a certain doubts in my function, maybe certain mistakes, how it is line by line it is executed, if you want to see, then what I have to do, instead of pressing F10, I have to go for step in, that is F11. So let me do this operation of step in. Now you may see directly it is jumping from main program to function program. Now see the structure of the function here. This is a function. You can also see the function name. What are the function name you gave in the main program? Same name you have to give. Otherwise, it will get confused. You are giving one name and here you are giving another name. That is also creates certain confusion, means error. So in this function, what you are doing, you are giving the variables input. Now these variables are local variables. Assume you completed all this function, you did the radiation, etc. Everything is over. After completion of this, what it is doing, it is assigning the results. What are the results you are expecting from this input? That these results it will transfer to your main program. This is your main program. Then I want to jump from one line to the another line. Let us say the continue. So I saw the function and I came out from function program to the main program. Now see in the main program, especially after calling from the function solar radiation function, you may see the results. What results I am getting from the function? That is at 12 o'clock, what the intensity of the radiation at that January 1st, what the day length, it is it is showing 10 hours at Jalandhar, and different values, what are according to our values, that's everything you can see from the function. So this is the difference between the line, that is a step and step in, what I am showing in the debugging slide. That the difference between the F10 and F11. And if you want to come out, that is the reverse, the step out, that means I showed this red dot here. If you want to remove this red dot, that means shift F11. You can press shift F11. If you want to put the stopper, stopper means set point or clear break point, this is F12, and exit the debug mode, the shift plus F5, or you may see here quit the debug. There is a red color square is there. By browsing this quit debugging also, instead of this keyboard, you may come out and go until cursor. Go until cursor I showed you just now. There is one option here, run to the cursor. You may put your cursor anywhere. Let me show. I am putting my cursor here without any set point or without any stopper. Then what I am doing? Run to the cursor containing the cursor. Then you may see it is jumping. My cursor is jumped to line number 91. You may see in the green color arrow. In the green color arrow, what I am doing? I am jumping that run to the cursor. Wherever I am putting my cursor, up to the cursor, you may execute all the lines at one step. Instead of step by step, all the lines you may execute one step by using this go to or run to cursor. And finally, once the debugging is completely over and you can exit the MATLAB, the control plus Q quit. This is Q is for quit option. Okay, I gave the commands for various logical, arithmetic, and various commands used in MATLAB. Okay, now finally, why we are doing all this MATLAB programming? To get the result, obviously to get the result. Okay, how to present the results? The first option is the plot option. A very simple command is plot xy. See, if I am typing plot xy, I am closing plot xy. I am closing without defining either line style or color or marker type. Everything it will control by default options. Means the color by default it will select the blue color. By default the curve or the line it will select the continuous line or continuous curve. And by default, if I am not defining any marker type means the specifier. It won't take any specifier. In engineering, we have to differentiate the simulation results and experimental results. In the simulation results, generally the results is presented in a continuous plots like continuous curves or continuous lines. Once it is you are showing the experimental results, you have to show some specifiers because mostly those are the observations. Even solar energy, if you are taking with the time step, that's 5 minutes time step or 10 minutes time step, then for you to represent each and every step as observation in the experimental things, what we have to do? We have to use this specifier, that is a marker type maybe. There are different types of marker types are available like triangle, rectangle, etc. So these plot commands, how to define this plot command? You may see plot xy, line style, line color, marker type, the marker type. So for example, plot x comma y, and this is the colon. Colon shows the type of the color, that's dotted line, and G stands for the color, which shows the green color for the line or the plot, the curve, and D stands for, this is the specifier, what we are calling as marker type. D stands for diamond point. There are many designs are available starting from stars, the triangle, rectangle, square, etc. D stands for the diamond point. And not only plotting, some subjects like engineering mechanics, strength of materials, and even engineering drawing, we have to handle lines. Let us say force, you are representing the force as a line. A line is a force is applied in a particular point in engineering mechanics, I am saying. So to represent this force or some direction, you may, instead of curves plot xy, you may use the line. See here, line x1, x2 in square bracket, comma y1 y2, and line color you may see red color, red line style. This is a continuous line, line width 1.5 points. So you may increase the thickness also by putting 2, 3, 4, etc. So what it is showing, you are drawing a line with the coordinates of x1, x2, y1, y2. That means x1, y1, x2, y2. You are meeting x1, y1 as a one point, and second point is x2, y2. So by typing this line in the MATLAB result, you may show as a line which family of lines. In case you are solving a problem, multiple forces in case of engineering mechanics. I use this line in my teaching. I'm teaching the first year engineers, engineering graphics. What I did is I solved all the solutions starting from projections of the points to projections of the lines, solids, and isometric projections, orthographic projections, including developments, everything, 100%. All these solutions I use this line command so that its background is it is a coordinate geometry. Without using any other softwares like CAD or AutoCAD, you may use this mathematics. You can show the results with the animation. I am showing you. You can show the results of this engineering graphics using these animations. I will show the ones completing my presentation on this programming. So I told you the line style, there are various styles are available. If you are not defining anything, by default it will take as a continuous line, which is also called as solid by default. And dash line, you may show this dash line like this, and dotted line, this semi-colon, dash dot. Generally, for example, if you want to show the axis, axis means long line, long short line, then dash dot line you may use to represent the axis. And the specifier, in case of you want to show the steps of this observation, experimental observation, maybe time step, whatever it may be, then see the line color with the specifier. So this is a marker type. Marker type for experimental, you may see the plus and cross symbol, the circles, hash, this star symbol, dot, square, S for square, D diamond, P is a pentagon, and H is a hexagon, means 6-point star. And triangle, you may see the 5 types of triangles here, and left hand direction triangle, right hand direction triangle, upward direction triangle, downward direction triangle. This is less than symbol, greater than symbol, and this is the power symbol. It is the letter V. If you want to select the colors, it's not the specifier actually speaking, it's a color. If you want to show the color and the letters, you may see the first letter red, or is red, G, green. But B, see the B for blue, but black is also coming first letter as B. That's why to differentiate the blue and black. For the black, most of the results are we are using the black. So that letter is K. K is for black and W for white. Others like C is a crayon, M is a magenta, Y is yellow. It's by default. I told you, if you are not giving any color for the curve or the line, by default it will select blue as a line color. And where you may use this white, sometimes the background may be, the results background may be color like black background, and you are showing the results in the white lines. Or you may use as eraser, as logically I am saying, if you want to erase certain results, you may use the white color. To hide certain results, you may use the white color. These are the examples to explain the various commands used in define this type of the line or the type of the curve here. The line width, marker edge color, marker face color, marker size. The example is plot xy This shows the dot shows this is a continuous line, a red color. This is O is the specifier. This is a marker specifier. Line width is 2, marker edge color black color, marker face color crayon. Face color means here it is fill. For example, there is a triangle. Triangle has two colors. One is the border color. The triangle has three lines, three sides. The three sides color is black color here, and fill color. The face color means this. You can fill the triangle with color of crayon. And marker size, maybe size of the triangle, you may select a small triangle or big triangle. That's specified here. The size is 10. So these are the graph functions. Plot linear. This is a linear plot. It may be the stem plot. I will show the examples. These different types of. Hello. इसमें म्यूट नहीं है, मेरा म्यूट नहीं है। हाँ हाँ हाँ। Yeah, 4 o'clock I am start. 4 o'clock I will close. अच्छा अच्छा अच्छा, ठीक है ठीक है। अच्छा अच्छा, I got it. So I designed this presentation. The first up to 4 o'clock I will explain these comments, and 4 onwards we can go for the practice of some of the examples, so that whatever I am explaining today, that's the various aspects in the development of the computer programming, and including these results like output plotting. You may practice starting from the input to output, including plotting, simple plotting. So I will stop up to 4 o'clock. I will stop my presentation. I told you there are certain inbuilt functions are available. While doing this engineering problem, you may use these options like the product, sum, that's total, square root, round, minimum, maximum, mean. Product BROD is a product, and differentiation, substitution, evaluation, simplify your functions. Like in mathematics, many times we have to simplify the complex equations and give the size and integration of the function with respect to certain variable, like divide integration of certain function y, and integration with the lower limit from the lower limit to the upper limit. There are many such options are available in the MATLAB, so that you can calculate easily. You can calculate those things. This is also like a plot. Let me give a brief introduction, so that whatever the practice I am giving today, those results you may show as a plot result. The basic fundamental lines in the plot is, let us say there are two variables. The simple plot I am showing here. It's x and y. In the x it is representing from 0 to 2 pi. That's up to 180 degrees here. And the step is here between 0 and 2 pi. The step is pi by 100. It has been selected here. And y is the result here. Y is the sin x. That means it is the sine curve. And plots xy represents automatically. It represents the sine curve. And see here, you didn't define any color or the specifier, etc. Then by default, what it is showing, it is a continuous curve. It is selected, and the color is also by default. It is showing the blue color. And you can also see there is no any marker type here. That's by default. It is not selecting anything. And after that, we have to define this label. We have to give the label to the x-axis and y-axis. X label is x is equal 0 to 2 pi. But here you are typing instead of pi symbol, because there is no option for type the pi symbol in the computer programming. That's why in place of pi, what you are using pi, you are typing pi. But if you are not using this symbol, that is a slash symbol, what happens? It will show as a pi only. In the result plot will show as pi only. That's why to convert this pi into the pi symbol, you may see the result of the plot. You can see the symbol only, not pi. For that, if the conversion is there, that is the slash symbol is used here. And similarly, y label also is given here. Sin of x, you may see the sin of x, and title of the plot of the sine function. This is the basic functions used in the very simple. In case you are using the multiple graphs like x1 y1 and x2 y2, use plot. Let us say the time t y1 t y2, and this is a grid on to show the grid lines, or grid off if you don't like to use the grid lines, that is a grid off. For multiple plots, let us say in one you are drawing only one graph, but in this one graph you want to show there are multiple graphs. Let us say graph 1, graph 2, graph 3, graph 4. First, what we have to do, we have to reserve the place for each and every figure. That is called as subplot option. Let us say here this is the time is 0 to 2 pi, and this is the y1, and y2 is t plus pi by 2. There is a phase change. And first, what we have to do, we have to define the location for each and every figure. So the first location, it is showing as subplot 2 to 1, 2 comma 2 comma 1. The meaning of 2 comma 2 comma 1 means this is there are 2 rows. In this place, I am showing these are 2 rows and there are 2 columns. So 2 by 2 is a place. Out of this 2 by 2, the first position is, this is the plot. This is the first graph. Similarly, subplot, after finishing the plot ty1, second figure is defined by subplot 2 to 2. So out of 2 by 2 matrix of these figures, this is the second place. So this is closed. After finishing the second figure, it is closed. If you want to show the third graph, we have to define this is a 2 by 2, that is a 2 to 3. The last one is 2 to 4. See, this is the example for this multiple plots. Let us say there's I told you there is a great power for this MATLAB plotting. There are 1 month results has been showing as a single figure. I am showing for one particular month, February. There are 28 days I am showing here. Out of these 28 days, the results of this laboratory observation, the dots, you can see the dots as a laboratory observation. This is the continuous curves, solar radiation as the estimated values by the students' observations. What we are seeing here, what type of command has been used here? This is the subplot option has been here. How many rows we are seeing in this single figure? There are 3 rows. And how many columns? There are 10 columns. So there are 30 places. We can draw 30 subplots here. Since it is a February month, in 28 plots only we are able to show. But every figure has certain location. For example, see this third line row. This is represented by first one, number of rows is 3 and number of columns is 10. That's why 3 comma 10 comma, what is this number we have to assign here. The first is 10, second is 10, the 20, the number is 21. So 3 10 21. Okay, I am showing a look at glance this plotting just options. One is there is a mesh option is available. If you, for example, if you have the values of x, y and z, how to represent this? For example, y is the function of x and y is your result. Let us say y is your result. One of the result, let us say this is the efficiency is a function of temperature and pressure in a particular power plant example. So to represent this result, that is a function of x and y, you may write the mesh x, y, z. You may see the meshing shape of this result, or mesh z, x, y, z. Once you are using this letter z, you may see the vertical lines for this result, or mesh contour. C is the contour. Contour lines you may see on the ground, and surface x, y, z. You may see the surface phenomena of this result of this x, y, z. Or surface contour. You may see the surface contour on the ground. Surface light. For example, if I am putting a torch light in any one of the corner, you may feel the solid nature of this, the 3D nature of this curve, XYZ curve. And this waterfall, that means I told you, depending upon the style of the presenter, maybe marketing or engineering, whatever it may be, he will use the suitable option. This is a waterfall, you may see like is slicing of this each and every curve. Let us say this is the performance curves of this typical system. And contour XYZ, this is completely the top view of this 3D picture of the 3D XYZ results. Contour is showing as temperature versus pressure, and that is earlier is the only contour. Now it is a 3D contour, then contour 3. What are the contours in the earlier plot? You may see in the XYZ direction. And results are, you can also add the shading as per your results. The shading may be flat, pasted, and this interpolation. There are certain loops here. The one is a switch case. According to your situation, the case 1, case 2, there are certain constraints or certain checking. If you, for example, if there is you are developing a properties to solve a chemical process plant. The fluid properties, if there are, say, as per the region or as per the conditions, you may evaluate the properties of this fluid using this switch case, like case 1, case 2, case 3, and finally it is closed by end. Similarly, this if statement, as usual, this is a if else statement and closed by the end. And I told you just now, this is a main program and followed by a function, especially this is useful to solve the components of the process, so that the process may be repeat in a particular typical process plant or typical power plant. Without any repeating those set of operations, you may do the function programs. And iterations, how to do the iterations, because to solve the numerical problems in engineering, we have to apply the iterations. In this iteration, in the coming lectures, I am going to explain the topic on modeling, simulation, and analysis. During that time, I will do various methods used in this iteration. The while loop is one of the options. You may define the constraint as a condition. If this condition is matched, it will come out with the results. Otherwise, the loop will continue till satisfying this constraint. And F0 is also one of the options where we can find the value of result, the function result. For example, there is one equation, the thermodynamics, there is a relation between pressure, temperature, and volume, PVT, the real gas. But this is the functions may be expressed as explicit functions and implicit functions. Explicit function means it is easy to solve, but this is it's not the explicit function, it is an implicit function. So iteration is required. So you may create the equation and you may use this, let us say, volume is equal to F0, and you may type the equation, that is Redlich-Kwong equation or Martin-Hu equation, whatever the equation you are using, real gas equation, and you can type these variables like volume, pressure, and temperature, and so that according to your given inputs, let us say the pressure and temperature has been defined. At this pressure and temperature, straight away with single line, it will give your results by using the command, that's F0. And you may also create the tables and the bar chart using this MATLAB. The bar chart not only single and comparative bar charts also you can use. There were, for example, there are two options in your project. Comparative study you may make using this bar chart. You may ask you how to make the animation in the results. It is a simple logic what I am showing here. Animations is you may, after finishing your programming, like I will give an example, movie. In the movie you will see the motion, how you are seeing the motion in the movie. It is dragging up all the films like 24 frames. A cartoon also you may see like this. Cartoon is a series of drawings. All the drawings you are moving with according to the phase, that is the speed. Similarly here also the results you may create the set of results. All the results you may move. That means represent the one particular result in one figure and display the second figure, third figure onwards. Between one figure to another figure you may maintain the time gap according to your speed, maybe slow motion or the fast track. So that you may see that line, draw now, pause 1 second. It is, I am putting 1 second or 10 second according to you that one. So there are series of plots as here in the for loop. According to the number I am giving here, that many plots it will show, and you may see like a movie by creating this type of animated plots. And sorry, I am taking more time. I will finish 5 minutes. Coming to the application part, I told you the MATLAB we can use in the teaching. See, instead of showing all these my demos, I have plenty of demos in subject wise. This is the one of the slide I am showing. See, the main advantage of this MATLAB is no need to depend on the freehand sketches. If you see the textbooks, any textbook, maybe electronics, mechanical, whatever it may be, most of the results they use the freehand sketch, including the results I am saying. So sometimes we may mislead the exact shape of the result. So let me give the example of this thermodynamics since I am teaching. If you see the shape of the Carnot cycle or any Joule cycle, diesel cycle, etc., it looks like big area, but once you are using the scale, that means x-axis, y-axis, the real scale, it may be academic problem or it may be laboratory problem. The realistic shape is completely different compared to the academic shape. So you may see the reality, you may feel or taste the reality in the teaching while doing while solving your day-to-day classroom problems as well as this project problems. I am showing this classroom problems as well as some of my project problems here. This is last one is one of the result, power plant result I am showing in 3-dimensional direction. Sankey chart, and this is the thermodynamic cycle. These are the properties. The realistic properties has been shown here, and this is the property chart and real gas compressibility chart. Everything has been developed using this MATLAB. And not only that subject I showed you, thermodynamics and refrigeration and air conditioning also. In the air conditioning, generally we have the psychrometric properties is required to solve or represent the air conditioning solutions. See, this is a psychrometric chart prepared using this MATLAB. While representing the refrigeration, you need to get the properties and pH chart, TS chart, and this aeroplane air conditioning has been shown, and this property chart using this scale. Now, there is no use of any freehand sketch here. And one more subject I told you, the engineering graphics. All the engineering graphics has been, that is the solutions of engineering graphics has been practiced and developed for the sake of students explanation. You may see starting from the scales to development, isometric projections, orthographic projections, projections of points, lines, solids, the sections, everything has been developed using this MATLAB. The background of this MATLAB, especially for this drawing, used is coordinate geometry. That is the beauty of this mathematics. And fortunately, I also got this the copyright for this work, even though it is outcome of my teaching for the subject of engineering graphics using this MATLAB. In future, I am going to do some virtual lab for this engineering graphics so that the students can practice the learning practice. I am saying they can develop their own solutions by defining the problem, nature of the problem, like the solids or projections or developments, etc. These are the some of the results I did for my subject of solar energy, and this is the heat transfer, and these are the students' projects. Not only teaching, the projects may at the level of students or the faculty, the industrial problems or the theoretical or experimental problems, they can use this MATLAB, especially to show the results in a more effective way, in a more professional way. These are the some of the projects done by my students. This is also storage system. The storage involves a lot of mathematical derivations here, because this is the transient simulation. The transient simulation has been executed using this MATLAB. It also can be solved using Simulink. This transient simulation results you may see from starting from sunrise to sunset for particular solar systems. And so the sunset geometry is more complicated. Even though it is complicated, easily we can solve using this computer programming. It's useful in product making, that's the product development, and process development. This is one of the biomass power plant process making. We did some case studies like cogeneration, power plant, etc. And we developed the properties for each and every process, starting from chemical to mechanical, power plant, etc. So without using any inbuilt functions, we developed our own functions, and so that we solve the solutions for the academic level as well as this industrial level using this MATLAB practice. Thank you for your patience listening. And now it is a time to you from your side. Whatever you learned now so far, that's some of the fundamentals, basics explained to develop the MATLAB computer programming. You may use to solve this problem. The simple problems I am showing here. I am explaining 4 problems. Since the time is now maybe available for 1 or 2 problems you may solve. This is the first problem. This is the physics problem. It is not related to one particular engineering like mechanical, because fluid mechanics is a physics problem here. In the fluid mechanics, I am showing the oil is at 20 degrees. This is a classroom problem I am showing. My intention of showing this problem is the students or the faculty can apply this the MATLAB for learning. For the faculty point of view, they can apply this MATLAB to teach the concept, maybe the numericals or maybe concept. They can take the help of this MATLAB and they may. This is the data given. I am not reading the problem. I will share you all these problems to you through the mail with the help of Dr. Manoj. This is the one variable is velocity. Velocity can be calculated from the pressure. The diameter is given, and these conditions are given: mu, viscosity, length, everything has been supplied. And this is the local velocity from the average velocity and the radius, local radius, starting from 0 to center of the axis to the boundary, that is r is equal to r, small r is equal to capital R. What we have to do? We have to find, plot the velocity profile in the pipe flow and print the discharge of the fluid. So there are 2 answers we have to develop here according to the given conditions, that is the temperature, density, viscosity, diameter and length and pressure. There are 2 pressures, 745 kilopascal and 97 kilopascal. What we have to do? We have to find the velocity, that's the local velocity, and calculate the discharge. So for that, see formulations already I am showing this formulation, that's the local velocity, average velocity and the local velocity. See the computer programming for these solutions, and also you are showing this local velocity, change in the local velocity from the center of the pipe. This is the pipe flow, laminar flow in a pipe, from the center of the pipe to boundary of the pipe, where small r is equal to capital R. First, what we have to do, okay, as usual, type clear CLC for the screen and type all the input parameters. In the numerical problem, the pressure is given, that is P1, P2, diameter, nu, length. Yes, type all these values. What are the values is given in the numerical problem, it is typed. And then what we have to do, cross-section area of the pipe. AC is equal to 5/4 d square. The cross-section area of the pipe is given as 5/4 d square. And the average velocity as per the given numerical formula P1 minus P2 into 1000, because that is conversion in kilopascal and pascal, d square divided by 32 mu L. So it is calculating the average velocity, and then volume is equal cross-section area into average velocity. Now in the for loop, because we have to calculate the local velocity at each and every point, how to select the local points? So radius can be changed from minus r to plus r. Yes, you may see small r is equal to minus r to plus r. How many steps you are taking? You may select here 0.1 times of radius. 0.1 times of the radius has been selected. According to your convenience, you may select this step in the radius. And how many points you are changing from minus r to plus r? So that is, you may take this as number of time, number n is a number here, size r comma 2. Or you may calculate also, the number may be calculated from final value minus initial value divided by total. This is a step plus, that means number of values. Let us say there are 20 values or 30 values, that you may calculate, or you may take the size of the matrix. Then create the for loop. In this for loop, you may see this local velocity has been calculated. All this local velocity at radius, let us say plot. You may see the plot. X-axis, what you are seeing, x-axis has been selected for the velocity. Y-axis has been selected for the radius. Since it is a horizontal pipe, the reverse has been selected. That is, input is y-axis and output is x-axis. With the vertical pipe, you may see do the vice versa. So in plot xy, that is u, local velocity and radius, and line width, the marker color, the k, and marker phase color, everything is defined here. And x label, the fluid velocity, y label, and the text is showing as laminar flow in the pipe. And you are also showing the result. What is the result? That is the volume at the discharge. Discharge has been displayed here as this variable is VOL. So after executing this programming, what you can see, you may see the result. That is each and every point, at each and every radius, you may see the local velocity and also the result. This is one of the practice I am expecting from all the participants. Could you do now? I will explain one more before going to the practice. This is the friction. I will show, this is not for practice, I am explaining. For example, let me show this plot here. This is a theta. Theta is changed from 0 to 90 degrees. And you may see at one particular angle, you may see this is a maximum. This is a function. What is this function? Let us say this is a friction force. This is the maximum. At what point, at what angle you will get the maximum. So without using too much of complicated lines or checking or comparing, simply you may create the equation and do, this is a F0. Find the F0. F0 means F0 where the 0 is getting, that's, let us say I am drawing a horizontal line. I am drawing a horizontal line at this function. Let us say this horizontal line is cutting at this point. Let us say theta is equal to 50 plus. So answer is 50 at 53.16 degrees. At 53.16 degrees, F becomes 0. That is the answer. You may do the solution here. The input and the function has been defined at the rate of variable. What is the variable at the rate of variable here? Theta. At the rate of theta, you define this function. So that at what point it is getting 0, f minus this function is equal to 0. So you may plot f 0 to 90 degrees. And you are also getting the answer from f0. up to 60, assume this is assuming here up to 60, assuming below 60 you are getting here by seeing this plot I am saying. So you may refine. For example, if I am selecting the range, large range, the accuracy will decrease. If I am selecting a small range, accuracy will increase. Similarly, this one also you can select the maximum value from this Planck's distribution law, that is heat transfer. This is the radiation law. As per the radiation law, you can also plot F plot option is showing here, X label and Y label. And this is the machine design, and you may see the stress, radial stress, and this is classroom problem. What I am showing everything is a classroom problem, but different subjects I selected here. And the field of, since I am the mechanical engineering faculty, I selected the problems for mechanical engineering subjects. This is the machine design. In this machine design, stress has been calculated, the radial direction and circumstantial direction as per the given data and as per the given formula. You may see after completion of this plot, that is computer programming. This computer programming is straight away give the data and type all the equations and calculate the radial stress and circumference stress and plot it. See, after seeing this plot, you may see I saw the same solution for the textbook. In the textbook solution, I saw this is a semicircle. The red color radial stress is showing as a semicircle. But after getting this plot from this MATLAB scale, that's a plot scale, it's not the semicircle. What I showed like shape in Joule cycle or Carnot cycle in thermodynamics. Similarly, the freehand sketch generally sometimes, and not always I am saying, sometimes we may mislead the shape because those are drawn by freehand sketch. That is one of the advantages I felt using this MATLAB, especially to solving the student level problems, classroom problems. This is a problem in the heat transfer, and the heat transfer, the boundary conditions are defined here. I will show only the solution, not the background of this problem. Let me define, there are certain equations. Let us say equation 1, 2, 3, 4, 5, 6. There are 6 equations and 6 unknowns. Let us say 6 temperatures we have to calculate. T1 to T6 you have to calculate. In front of you, don't worry about this mass balance, energy balance, heat balance equations, how you are doing using these boundary conditions. Those are different because I am giving the results directly. There are 6 equations are there. Now you are feeding this problem to the MATLAB. What MATLAB is doing, simply type all these equations. For example, you have 100 equations. Type all 100 equations, and only one line, the last line will solve all 100 equations, and it will result 100 results. Let us say there are 100 temperatures we are expecting from the 100 equations. All 100 temperatures you may get as a result from one line only. That is a powerful line. You may see here. I'm not explaining all the lines here. Equation 1 up to equation 6 it is typed, and you may see the last line solve, SOL, solve and solve equations. Equation, this bracket represents all the 6 equations, but before that you have to define symbolic objects here. Dr. Pramod is going to explain the symbolic math here. All these variables are defined. T1 to T6 has been defined as S5MS. Then you may solve this function, that is the 6 functions or 6 equations, and finally what you are assigning, the results we assigned as T1 to T6 as one line, one array, and dimensions like this is the block, 2-dimensional block, x-axis and y-axis, so that you may plot x, y, z is the temperature here. After plotting x, y, z, there are 2 types of plots. You may see the first one is showing the contour plot, that is the temperature lines has been shown here, and next is the color, that means the interpolation of this temperature. With one blue color shows the lowest temperature, let us say the 0 degrees centigrade, it's maintained. Another side red color it is showing it's let us say 100 degrees centigrade is maintained according to the boundary conditions I am saying. So the results like ANSYS, the results we are representing both in contour form as well as this 2-dimensional temperature field in the color form. Thank you all participants, and now you can practice. I think so. I explained four problems. This is academic problems. What I explained, these four are from the subject, from the textbook I selected. Any one of you, maybe according to your interest, out of four, any one of you maybe you may practice. But I'm expecting the first one is very simple, because this is a physics, the first year engineering. Every one of you studied about this fluid mechanics and the physics problem. That's why I may expect you may solve this problem. Now I want to interact to you participants. You may have certain doubts and need some clarification from my explanation. Now I want to interact with the participants. Dr. Manoj.
Sir, please tell me.
Is there any questions from the participant side? I wish to interact. Otherwise, straight away I will give the problem. How to transfer the problem to the students?
Yeah, we can post the problem, or it's better I can mail them.
I will transfer to you. I will transfer to you that problem.
Yes, you can transfer to me. Then I will post it.
Okay. And before that, before assigning this problem like a homework to the participants.
Yeah, it would be nice if they will practice it. Then only they can run it.
Yeah, homework
means they can learn. Otherwise, it's just like a video or not. Yes.
I will give four problems.
Yeah, my suggestion is they should practice.
I will give four problems.
Yeah, it would be nice, sir. Give it.
Okay, thank you.
Okay.
Hello.
Yeah, hello.
Sir, thank you very much for this excellent lecture to us about the very much, introduction about MATLAB. Sir, like my fellow classmates, I am not an engineer, but a commerce graduate, BBA, MBA, then Commonwealth Scholarship, MSc, LSE UK, as well as a CA from there. So my humble request to you is that, sir, in this shortest period of time, the aspect of MATLAB is so vast that it is not possible to showcase everything within this shortest period of time. That's why I am humbly requesting you, sir, if you please be kind to us to provide us one or two very excellent book as reference, so that I can practice it very well. And I'm really very interested to learn it, sir.
Definitely. Dr. Manoj, I think he already shared one book, I think so, today morning. I saw.
Yes, in the WhatsApp group. In the WhatsApp group, it has been shared.
Yeah. Sorry, today I'm getting cough. Sorry, due to weather changes. Yeah.
Okay. So I guess in the WhatsApp group, sir has actually shared us. A book. That is the book actually you are suggesting as well, sir, or any other book actually for us. The non-engineers I'm talking about.
Yeah, general. Actually, we have material. I will share with Dr. Manoj, and I think he will forward to all the participants.
Okay. Thank you very much, sir. Thank you very much.
They're very general, not engineering. It's a general commands. Yeah.
Thank you very much. Because, sir, MATLAB has some flavor that is quite unique. For example, to manage the supply chain management, to deal with the logistics, we are regularly using that genetic algorithm. We are regularly using that meta-heuristic algorithm. We are regularly using the naturally inspired algorithm. But the fact is that my colleagues who are actually engineers, they are developing it. I am not being able to communicate with them properly about the demand of the industry. That's why we are not being able to reach out to the proper management and application scenario. I hope, sir, you can understand my point.
Yes, you are correct. I will share my side, whatever I explained today. I will share all the information in the PDF form.
Thank you very much, sir. It is so kind of you, sir. Thank you very much, sir. And I'm really grateful to honorable organizers, sir, for allowing me in this excellent class to learn a lot from prudent professors like you. Thank you very much, sir. Have a nice day, sir.
Thank you very much. Any
Hello,
else?
sir.
Yes, yes.
Hello. Yes, sir. Sir, actually, I'm having one query that we can drop two-dimensional plot and three-dimensional plot in MATLAB. But sir, is there any option to? I mean to say, suppose I want to draw one four-dimensional plot. In that case, I have to consider that suppose the third one is constant. So, is there any other way to deal with the higher dimensional plottings in MATLAB, like four dimension and up to five dimension, six dimension, something like that?
Yeah, plotting difficult because we can't see the four dimensions, but the multi-variable optimization we can do. In multi-variable optimization, let us say, I think I'm going to take one more class. In that multi-variable optimization, what I'm going to explain is, let us say Z is a function of certain variables like x1, x2, x3, x4. Mathematically, you can solve the solutions by changing all these variables. Maybe two variables you may change, or three variables you may change, but representing graphical representation is a more complex in nature. Means what I noticed from the student side, they are not able to interpret the graphics, but by properly selecting the axis like primary axis, secondary axis, you have freedom to take the primary x-axis, secondary y-axis. Yes, it is possible. And also see, generally in Excel means, let us say y is a function of x. What we will see, x-axis is the input, y-axis is the output. But in the MATLAB, x-axis also you may select as a result, for the result I am saying. Y-axis also you may select for the result. Are you got my point?
Yes,
I have
yes.
some sample graphs, but I have to search the bunch of results. I have plenty bunch of results. If possible, I will show later. X-axis you may select as a result. Y-axis also you may select as a result. I think Dr. Mano is also going to explain some special curves, 2D and 3D. Anyhow, I will show some of my results, what I selected for x-axis and y-axis as a result. And so now you may see some of MATLAB results. This is the development of surfaces. I think every one of you, irrespective of your background, you might be studied engineering drawing. I didn't use any software like CAD, etc. Only mathematics. MATLAB means mathematics, the matrix laboratory. See how you can't find the difference between what you are seeing in textbook or AutoCAD. This is exactly drawn to scale, the dimensions and the results. And also you can see the animations, the step-by-step development, so that it's easy to explain the students the concept. It may not be drawing, it may be some other subjects, maybe you are explaining the graphic theory or whatever it may be, circuits, etc. You may add this animation so that it's easy to explain in a step-by-step manner. And all these MATLAB results, the solutions I am saying, all these solutions, the graphical solutions are available in the YouTube, starting from points to solids, everything is available. I solved everything using this MATLAB only. Due to time being, I didn't demonstrate it. I have many demonstrations for examples for this MATLAB.
Okay, thank you.
Yes, yes.
Sir,
Any else?
simulation part I will tell them.
Yes, okay. This is some solar tracking. You may see sunrise to sunset, how it is moving. This is the right hand side, the angle, and the mechanics like engineering. Engineering mechanics means everybody knows the results of engineering mechanics. And first drawing shows the shape like parabola, focal point, etc. And any else? Let them move parallelly, the results. Participants, any else? Any questions from your side?
Sir, I am having one question.
Yeah.
So suppose I have used once a variable, suppose I have used variable a is equal to cos x plus sin x, right? So while doing the programming, suppose I forget that I have already used the variable a is already used. Suppose again I use same variable a is equal to, I give some different values, say cos x minus sin x. So same variable, two different values are given. So can I come to know that this variable is already used?
You are asking the coding
Yeah.
Coding or plotting side or coding side, I'm saying.
Coding side, coding side.
Coding side, yeah, yeah. Coding side, yes, yes. We can give the commands different array. Yeah, if you are putting in array, there is no problem because whatever the variable name is same. Let us say you are calling X.
Yes, sir. My question is ki I have to at that time I have to give some different variable. Na say B. I suppose I give the same because I forgot ki I have used the variable A.
Yeah, it's possible. Coding, it's possible.
Sir, my question is.
Sir, excuse me. Actually, C is telling that. Just I'm interrupting. I'm sorry, sir.
Okay, okay. Manoj, proceed. Yeah, Dr. Manoj, proceed. Programming side, I'm thinking.
C is saying that a variable A, its name is A. C already defined.
Yes, sir.
And C forget about this. C has defined a variable name. Its name is A. And it's the same name, that means A, C is using somewhere else. Am I right?
Yes, sir. Yes, sir.
No, it is not possible, madam. It is not possible. You have to keep record.
It will replace.
Otherwise, previous variable, if you are keeping A, it will be overwrite there.
Yeah, overwrite means it will replace. Yeah.
That is replace.
Actually, the program is so much lengthy, na. So sometimes if I forget ki I have already used, so this happens with me generally.
Yeah, it's right. Yeah. It's happened with us also, madam.
Yes,
but
sir.
Slowly, we will be expert. But we have to play with this software first of all.
We can assign some other value also. There is
other
no
value
issue.
also. That means A1, A2,
Latest
A3,
value will
A4
assign.
like this.
Latest value.
My question is ki can the MATLAB tell us ki you have already?
No,
never.
Okay,
never,
sir.
Never.
Okay, sir.
It won't help.
Okay, sir. Thank you.
It's automatic. It will take whatever they assigning.
Yeah, this is the
it will
general mistake.
If you want to know, you have to give like display. One example I told you. You will give some condition like repetition condition. It will give some alarm. That is checking filter. In my computer coding, generally I will use filter. Filter means every computer loops, computer programming, main program or function program. I will give some filter so that what are the constraints I have, whether it is satisfying or not, like repetitions, etc. If it is deviating from my main idea, immediately it will give the alarm by displaying so and so variable is deviated. That is possible.
Okay, sir. And you have used one command sprintf. What is this command, sir? Output command. Na? We generally use fprintf.
Yeah, that is for sprint is, for example, if I want to display a number with certain expected decimals, like let us say instead of 5.0, the other decimals also I want to display like 5.0.0010032, then according to your expectation, 4 digits or 5 digits, you may type.
Okay, sir. Thank you, sir.
Okay, thank you. Yeah. Any else?
Hello, sir.
Harish. Who?
Hello. This is Sarath, sir, from KL University.
Yes, Sai Sarath. Yes.
Yes, sir. A small doubt, sir. You shown 4 problems related to mechanical engineering. First one is velocity profile problem.
Yeah, that's a fluid mechanics.
Laminar flow. So, sir, in that problem, you told that that radius minus r to plus r.
Are you able to see the screen now?
Now I am able to see the screen.
Minus r. See, the origin is 0. Axis is 0. That's why minus r to plus r.
That's fine, sir. This r is 0.025. This range 0.1 into r you have given. I think in place of this we can give that straight away that number, sir.
Yeah, we can give numbers also.
Okay.
This is like, see, any diameter we can select, or any radius we may select, like more flexibility.
Okay.
Yes.
That's fine, sir. Okay.
Yeah. I will share this information. That's problem definitions. All four I will share to you so that you may get some inputs.
Okay, sir.
After finishing this program, I will share to Dr. Manoj.
Sir.
Sure, Dr. Manoj.
Yeah. Even sir, I can share that email ID and all details to you. You can also directly send to them.
Group. Okay. Yes. Group mail ID. Okay.
Group mail I have.
Sir, excuse me.
Yes, please.
Sir, I mean, I have an issue. Please don't mind. I mean, regarding that email ID, when I have registered, my usual email ID shamim.active@gmail.com was not being accepted during the registration procedure. That's why actually I have used different email ID. Sir, is it possible to include my usual email ID to the group as well, please?
Yes, why not?
Thank you very much, sir. So
Yes,
I am going to email you right now.
You can only
from my
mail us,
email ID.
right?
From
Right.
my email. Okay.
Yes.
Okay. Thank you very much, sir. Thank you very much for being so kind.
Right.
Thank you.
One more thing I would like to tell you. Today I will share Google Form once again. Actually, what I found that in Google Form, many of our participants wrote that the short name of their institute, whether they are faculty, where they are PhD student or employee, they have not written there. So whenever we will be making certificate, at that time we need all the things, all the details. So today I will send, kindly do perfectly, kindly fill the things perfectly, so that your that means certificate would be clear, that means right, everything will be right there. Okay.
Thank you, sir.
Yeah, it is fine. Yeah, it is fine, then it's okay. Now hello.
Yeah. Yes.
Now we can leave, sir.
Yes. Okay. Tomorrow what time?
Tomorrow 10:30, sir.
10:30. Okay.
Yes.
Okay. Thank you. Bye, one and all.
Thank you, everyone. Have a nice day.
Thank you, sir.
Thank you, sir.